Whether you're an experienced Salesforce admin or an absolute beginner, this crash course in Apex will get you acclimated with how Salesforce works, specifically the Apex programming language, how we can use this programming language to build applications. In this specific course, we're just going to be focusing on the fundamentals of Apex programming, going into variables, classes, objects, pretty much the rudimentary things you need to know and the concepts you need to know in order to get started with Apex programming. So with that being said, let's get started. So before we dive into some code, let's give a brief overview of what Salesforce Apex is. Generally, we'll be looking at how we use Apex and why we use it in the first place on the Force.com platform. We'll also be looking at the main tool that we'll be using is Visual Studio Code, but you can also use Developer Console, and I can show you guys that briefly. And then finally, we'll follow up with some live coding to show how to define various variables, objects, working with classes, and so forth. In this course, we're going to keep things very simple. We're not going to delve too deep into anything like writing data or saving data or triggers. I'll save that for other videos that soon to follow, because they're more advanced topics, and I don't want to cloud things by introducing very advanced topics. So we'll keep things very simple for this very first video. So going deeper into this, Salesforce is a proprietary object-oriented programming language. Now, you probably heard the term object-oriented programming many times before with other languages such as Java, C#, Python. But what we mean by proprietary is that Salesforce was specifically developed to be used on the Force.com platform, because the Force.com platform is known as a PaaS, or a platform as a service. So generally, we can develop any app that we would like on the Force.com platform using Apex on the server side. Apex is strongly typed, generally meaning we specify what data types we want to define within our variables. For instance, if we want to define a number, we'll say integer x equals and so on. And we do that so that the server is able to compile that code and check for errors at compile time prior to runtime. So being that it's strongly typed, it gets converted into bytecode when it's stored on the server and run. If you're coming from a different programming language such as Java or C#, you'll find that Apex looks rather similar to those programming languages, which is good because you're able to transfer your skills from those programming languages into Apex. And most developers who transition from Java backgrounds or C# backgrounds find that they can learn Apex within a week or two. I wouldn't say you can master it that quickly, but it's definitely something you can feel comfortable with after about a week or two of constant development on the platform. So Apex works seamlessly with data, otherwise known as S-objects or Salesforce objects, and metadata, which could be standard and custom. So basically what S-objects are, they're Salesforce objects that we use to store data within Salesforce. You can refer to S-objects as sort of as being database tables, if you will. And metadata is generally defined as being standard or custom. We have certain objects in Salesforce that come by default with a specific cloud flavor. So you have, for instance, the Sales Cloud flavor, in which you have objects such as opportunity, account, and contact. Those are standard objects that have metadata underlying within them that describe exactly what the object looks like, what kind of fields the object contains, and so on. And then we can also define our own custom objects in Salesforce, which would then have custom metadata to describe what those objects are. So as you can see, S-objects and metadata work hand in hand seamlessly, allowing developers to write powerful applications on the Force.com platform. Many developers can sort of transition very easily into Apex if they know those programming languages. So now you might be asking, why do we use Apex in the first place? We could develop applications and build logic in Salesforce through declarative programming, which is generally using out-of-the-box tools such as Process Builder, Flows, and various other tools such as Workflow Rules to build Salesforce logic. But more often than not, a lot of enterprises choose to go the Apex route if they need to build something very complex that's scalable. So Apex is used, for instance, to run CRUD operations where we create, read, update, and delete data from the server within a Salesforce org or a Salesforce environment. And generally we use Apex to communicate with that data, communicate with S-objects, and handle various operations within the Salesforce platform. We can also call API routes. We can communicate with external APIs and bring that data into Salesforce and also pass data out of Salesforce. So it's a very flexible platform, and Apex allows us to easily communicate internally and externally from the platform. Now, also we use Apex to access metadata. We have the metadata API if we need to change various elements within the metadata itself. So generally, we can communicate with the metadata API, for example, to change various object definitions within Salesforce. And we can easily do that by calling specific endpoints in the metadata API through Apex. Now, also the one other big piece of Apex is that we're able to build tooling. So there we have the tooling API that we can leverage to build tools within Salesforce. A common use case for this is if you work for an ISV, which is generally a firm that has a special partnership with Salesforce Incorporated, where you can build Salesforce applications to be sold on the App Exchange. So Apex allows us to build powerful applications that we can turn around and then sell to users who would then subscribe to our service through the App Exchange. So as you can see, Salesforce Apex is definitely a multi-purpose language with which we can build very, very powerful applications that run in the cloud. So when it comes to writing Apex code, developers choose one of two routes. They can either log into Salesforce, and in the top right of Salesforce Lightning, you can click on the gear icon and then click on Developer Console. And what that will do will open up a prompt window, which will then show the Developer Console pane. And within that pane, you can write Apex code, classes or triggers, whatever have you, to write logic within the Salesforce platform. While that works, many developers choose to use Visual Studio Code for its flexibility. And you can also install additional extensions to support your coding. So that's what we're going to be doing in this video. So before we get into any coding, we need to get two things set up: Visual Studio Code and Node.js. Visual Studio Code is our IDE, or our integrated development environment, that we'll be using to build Salesforce applications. And we need to have Node.js installed, which is commonly used for installing packages because it contains the Node Package Manager, or NPM. And that's what we're going to be using to install specific extensions or this is Salesforce CLI, for example. So the very first thing you want to do is look in the video description for these two links. Here, as you can see, we have the Visual Studio Code installation page. Since I already have that set up on my computer, I'm not going to reinstall this. So just go to this page and click on download to get that started and follow the prompt to get that installed in your machine. The second thing you'll need to do is get Node.js installed, which is commonly used for installing various packages or extensions using the Node Package Manager, or NPM. So make sure you go to this page and install the correct edition for your machine, whether it's Windows or Mac. So after you install Visual Studio Code and Node.js, the next thing we want to do is create a brand new folder. And the reason why we want to do that is because we want our Salesforce project to be located within a specific directory on our computer. So where I'm going to put mine is within a folder called Salesforce-Apex-Crash. So I'm going to create that directory. So I'm going to just navigate to my development projects directory. And in this directory, I'm going to type in mkdir Salesforce-Apex-Crash. And what that's going to do is going to make a new directory or a new folder within which I can add my Salesforce project, if you will. So I'll hit enter on that. And so if I cd into that, cd Salesforce-Apex-Crash, now I can type code dot, and this should open up Visual Studio within this folder. So as you guys can see, it opened up Visual Studio. Let me just enlarge this. Great, so now we're within this directory. So now what we want to do next is we want to install an extension specifically for Salesforce. And that extension is called Salesforce Extension Pack. It contains a collection of various different plugins we'll be using to write our Apex code and run specific commands and compile. So right here in the bottom left of our window, we have a cog or a gear icon. So if we click on that, let's go to extensions. When I click on extensions, all I need to do here is type in Salesforce in the search bar. Now, I already have this installed, so there's no need for me to try to reinstall it, but this is basically the one we want. We want this Salesforce extension pack, so go ahead and get that installed, and it should just take a few seconds to get that set up. And then once that's set up, we'll be all ready to write Apex code and to get our Salesforce project up and running. So next, what we want to do is we want to run a few commands in our terminal. So I'm just going to go back up here, and I'm going to click on this page icon, if you will, and then I'm just going to open up a new terminal at the top, terminal, new terminal. And the first thing we want to do is we want to install the Salesforce CLI version 2. So Salesforce Incorporated just released a brand new CLI version for the Salesforce DX project. And basically what this is doing now is it's making it a lot more optimized to run these commands within a terminal. Things have gotten a lot better in terms of how the commands are written. They're shorter in some cases. So we're going to be using version 2. If for some reason you have CLI version 1 still installed, I would suggest you look online on YouTube. There's tutorials on how to convert or upgrade to version 2 or how to completely uninstall version 1. That's exactly what I did because I think version 2 is a lot better and a lot more optimized. So to get started, I'm going to run a command here, and I'm just going to copy and paste that in. Now this command is npm install @salesforce/CLI-global. And what that's going to do is install this Salesforce CLI version 2 globally within our app, within our computer. Now I'm not going to run this because I already have Salesforce CLI already installed, but you guys should go ahead and type this command in word by word, just to make sure that you have that installed on your machine. So after we install the CLI package, let's just check to see if that has been installed correctly. So we're going to type in SF version, hit enter, and as you guys can see, I have version 2 installed of the CLI. Great, so far so good. So let's see here. The next thing we want to do is we just want to make sure that npm or Node.js had been properly installed. So to do that, we're going to say npm -- version. And as you can see, I'm running on version 8.1.2. Your version may be different, and that's okay as long as the commands work. That's perfectly fine. Okay, so it looks like we've been set up and pre-configured with everything that we need to get up and running. So the next thing I want to do is I want to create a brand new Salesforce DX project. Now, just a little bit of context on what Salesforce DX is. It's part of the developer experience or DX of Salesforce. So generally we have non-DX projects in Salesforce and we have DX projects. And a non-DX project is sort of like the old way of building Salesforce applications where we have a predefined folder structure that has objects, for instance, various types of metadata, workflow rules, whatever have you. We have a Salesforce DX concept, which makes it a lot easier for us to get up and running and get our project nice and flexible for us to develop. So we don't really have to follow a predefined folder structure with building our Salesforce app anymore. With Salesforce DX, we have the flexibility of building whatever folder structure we'd like as long as we have the main dependency files and folders in place and we don't tamper with them. We can actually build different folder structures and architect our project to be a lot better. I'm going to keep things a lot simpler in this course. I'm going to go with the default suggested project folder structure that Salesforce gives us out of the box. So first, let's get a new Salesforce DX project up and running. To do that, we need to run a command. So just follow me here as we type along. It's going to be sf project generate -in, and then we want to give it the name of the project. In this case, we're going to say Salesforce -apex-crash, and we're going to hit enter. So it looks like that's been set up for us. So let's go ahead and take a look at some of the folders within this project. So if I expand this Salesforce Apex Crash folder, we see we have a list of folders and files within it. And so let's just take a look. We can ignore .husky. Let's go first to this force-app file. So if I expand that, Visual Studio Code automatically drills down to /main/default for us. And as we can see in the default folder, we actually have various component folders within here this project. And these folders represent metadata on the Salesforce platform. For instance, we have our standard Aura controllers and Aura JavaScript-based components. And then we have our Apex classes folder. Now, at the current moment, we don't have any Apex classes. We haven't created any, so this folder should be empty, but we will be doing that shortly. And then we have other types of folders here. For the most part, for this course, we're going to be working with just the classes folder. In the future, we're going to be talking about Apex triggers and SOQL, or Salesforce Object Query Language. But we're going to keep things simple, as I said before, for this particular crash course. So if I just collapse this, the other folder we're going to be dealing with here is called scripts. So if I expand that, here we have Apex and SOQL. We'll just be working with the Apex folder, and within this folder we have a hello.apex file. And if I click on that, you can see we have some comments here and some example code. So the very first thing I'm going to do is I'm going to rename this folder, or rather rename this file. Let me just expand that again, and I'm going to call this one, let's call this, instead of hello.apex, examples.apex. So I renamed that file, and then the next thing is I'm going to just get rid of all these comments and save. And the reason why I'm going to do that is all of the examples that I'll be showing you guys today will be written in this file. So basically, just in a nutshell, what this file does, it runs an anonymous script on a Salesforce server. We're executing code anonymously. And when we do that, that means we don't necessarily need to compile the code within this file. And that makes it a lot easier for us to test various code blocks, or certain logic that we would like to preview before we actually write it into our application. So we'll be working with this today to keep things rather simple, so we don't have to define special components or objects or classes to work with in this case. So one other thing we want to configure before we get started is our sfdc project JSON file. And there's one slight tweak I want to make here, because I had some issues when testing things out here. I want to change this Salesforce API version from 59 to 58. And the reason why I'm doing that is because in version 59 at the time of this recording, I was having several issues with compiling certain things. So I'll definitely need to report that to Salesforce so they can look into it. So if you're using something higher than version 59 at the time of you reviewing this video, go ahead and stick with that version as long as everything works. Otherwise, you can roll back to version 58 to write your code. In addition to that, in conjunction with this change, any classes or metadata we'll create will probably also need to roll those versions back to 58 as well, just to keep things in unison with one another. All right, so let's see. The next thing we'll do is let's start writing some of our code, guys. So let's go back to our examples.json file. And one thing I'll be doing in this course, which is a very quick way of flipping through files, is I'll be using a shorthand or a short key to kind of go through various files. Now, if you're on a Mac, you can hold the command key and hit the P button or the P key to open up this prompt. And in here, you can type the name of the file that you want. So in this case, I'm going to type examples.json. Now, I know that this file was already open at the time, but I just want to show you exactly how to access that. And actually, it's examples.apex, not JSON. So opening this here, we're back in our script file. So I guess the very first concept I want to show you guys is how to work with various types of Apex concepts. There's a few steps of pre-configuration we'll need to do here before we jump into our main concepts. So I guess we'll start off by creating a method. And what a method is, it defines behavior within an application. So a common example could be, for example, you have an object called person, And what do? People walk, people talk, people eat, people sleep. So within an application, you can define methods to symbolize those specific actions or those specific types of behavior. So in this case, our application needs to run. So I'm going to create a brand new method called run. And I'm going to define that as a private method, and I'll explain that shortly. Private void run. Let's just open up our curly braces, and this is generally how we define a brand new method. We define first the access modifier, in this case private, then we specify void if we do not want to return a value from this method, and I'll go into that shortly. And then we give the method a name. In this case, I want to call this run. You can call it anything you want, but usually as a best practice, you want to make things as descriptive as they can be. And then we have our opening and closing parentheses followed by opening and closing curly braces. Now, just to kind of define exactly what this means here, private basically means that no other part of our application can access this method. So nothing within our application, this is only private to this specific file. Now, being that this is a script file, I really didn't have to say private, but I just want to introduce you to some of the access modifiers within the Apex programming language. And the good thing about this is once you learn this in Apex, this can also transcend into other programming languages such as C# and Java, because they also use private and public and other access modifiers. And that's what I mean by Apex being very similar to those other sort of flagship programming languages. So then we also have the void keyword, and what the void does is this specifies that this particular method would not return any value. So if we wanted to return, for example, some text, we can also say private string, and string symbolizes text. So if we wanted to return a number, we can say private integer. Mistyping that, integer, right, to return a number. Or if we wanted to return an object, we can say private person, whatever object we create. In this case, we don't want to return anything, so we'll just say private void, and then we gave it the name. So that's pretty much in a nutshell how a method is defined, and you'll see a little bit later exactly what we mean by, or how we use these methods to communicate with objects in state, which are the variables and fields and attributes within Apex. All right, so moving along here. What we want to do within this method is we want to call other methods, and I'm defining it this way to make it nice and clear what I'm doing. So for now, we'll just skip defining those methods, and down here I'm just going to type in run, opening, closing parentheses, and a semicolon. The semicolon specifies the end of the instruction or line of instruction, if you will, and it lets Apex know that this is the end of this line. So look at the next line for the next set of instructions. And what this will do is this will actually fire or trigger this run method to run. Without this, run would do nothing. Nothing would run because we need to specify that by using this line here on line number 5. So now that we did that, we'll go back up soon and we'll define the actual behavior within it. But before I do that, I'm going to go down here and I'm going to create another method, and that's going to be private, if I could type correctly, private void. And let's see, I would like to have a method that would debug or output specific values to our console. And the reason why I want to do that is I want to be able to show exactly how things work in Apex in terms of values and assignment and calculations and things like that. So I'm going to create a method called debug. And in this method, we can give this method an argument. So I'm going to give this an argument of string, and I'll explain this in a second. We're going to give it a tag argument, and we're going to give it an object argument, which will be a value object. Now, basically what I did, why this looks different than compared to above, is because we're giving this particular method 2 arguments. And so we have to define 2 parameters within this signature, within this first line here. So first, we're going to pass this argument a value, which is a text value or a string that would represent basically some text that we will output prior to outputting the value. And I'll show you that in a second. The second argument we're going to give is just a generic object That can be a string, it can be an integer, it can be another object, and we're going to pass that in as a value object. And the reason why I'm passing it in as an object instead of, let's say, a concrete string or whatever else is because I'm not sure at the time, before runtime, I'm not sure exactly what kind of object it is. So it's just safer for me to pass this in as an object and then just to cast it or convert it to its respective data type once I figure out exactly what kind of object it is at runtime. All right, so within this method here, let's see. What I want to do is I'm just going to output this value, and we do that by using the system.debug method in Salesforce, and I'll explain to you what that is as well. We'll just kind of explain things as we go down the line. So just type this out first. So we'll just add that in, these 3 dashes within a single quote or a set of single quotes, and then we're going to output the tag and then plus. Let's see, how do I want to do this? Let's do some more single quotes and then a colon plus, and then we'll just output the value object. Now, because we're just outputting the object value or the value object, I don't really need to cast it because we're just outputting the value. But in a real world application, if you have a scenario like this where you're passing in an object and you're not really sure what the data type is, you might want to check using the type of keyword within Apex to check, is this a string, is this an integer, is this a type of object, prior to you processing or further parsing the data. And you want to do that to avoid error messages. But since we're just doing a simple output, there's really no need to do that check here. But you can look up more information on that in Salesforce's documentation. So let's just kind of backtrack here and explain what I'm doing. So first off, the system namespace within Apex has a function called debug, or a method called debug. So system is basically one of the base classes or namespaces within Salesforce Apex that contains utility methods that can be used within Salesforce Apex to do things like output information to the screen or take in information, or various other interface implementation methods and so on. So we're going to be using this system.debug to output values to the console. So having this will allow us to see exactly what these values are as we work with them. All right, so hopefully that makes sense to you all. So let's see, I guess the very first thing we can do here is we can demonstrate how can we output something to the console. So we want to be able to just output a basic value to the console here below within our terminal, so that way we can see what the output is. So I'm going to go back up to my I'm going to go back up to my run function, and I'm going to add one called print to debug log. And a debug log in Salesforce is basically just a document that shows a trail of execution. So a good example of that would be it's going to show what kind of database queries you've run, what kind of output values are being shown like within the trail of execution as the application runs. So the debug log is usually used to debug as it intends, or as it's stated here, to debug or trace error messages within Salesforce. So we have this print to debug log method that we're going to create. So then now I'm going to come back down here, and whatever I type within that run method, I have to define down here. So we're going to say private void print to debug log, and we're going to open that up. Good. So now what do we want to do? We just want to simply output a message to the debug log. So let's do that. So I'm not going to use the debug function for this first one because I want to show you guys something. So let's just give it a simple message. Let's say system.debug. And what do we want to debug? Let's just do a simple hello world application. So hello world. This is a very common thing you'll see in a lot of programming languages. So now once I run this, this is going to output the hello world, basically going to output hello world to the screen. So the very next thing we want to do is authorize our org. with Visual Studio Code. And we need to do that so that Visual Studio Code can communicate directly with Salesforce. So we're going to go back to our terminal down here, and we're going to type in sf.org login web, and we're going to specify an argument of -a, and we're going to give it an alias name. Now this alias name that we give it will directly correlate this org with a particular name. So that way, if we're working with, let's say, 10 various orgs, each one of them could have an alias. So that way we don't have to type in a username every single time. We could just type in the alias to specify which org we want to work with. In this case, I'm going to call this one Salesforce with a capital S, Apex with a capital A, and Crash with a capital C, all as one word. And if I hit enter, off screen, you guys, you should see, for me off screen, it shows a brand new tab asking me to log into Salesforce. It should show something similar for you. So what you want to do is just go ahead and log in with your Salesforce username and password. And once you do that, if done successfully, it should give you an authentication complete or successful message. And once that happens, you can just simply close out of that tab and you should be good to go. So now Visual Studio should be authenticated with Salesforce. So now the next thing we want to do, as I mentioned before, is we want to run this anonymous script. We want to execute this anonymously so that way we don't have to really compile it directly on the server. Again, that step of authorizing our org was just to kind of set up the connection with Salesforce in the event that we do need to compile something directly on the server, so that way we don't forget to do it later on. So next up, what we want to do is we want to execute this script anonymously by running a command. Now, before we do that, we actually have to cd into our project folder, because if I check what is in this folder by typing in ls enter, we see that we're currently not in our project folder. So we actually have to change directory. So let's do that. cd Salesforce Apex Crash. And now we should be in the correct folder. So if I just do pwd, we see the route of this folder. And if I type in ls, we see the contents. That's great. So now what we want to do is we want to run this script. Okay, so I'm just going to clear this. And to run this script, because we're generally running Apex, we type in sf apex run, and we specify a couple of arguments here. So the first argument, which will be -o or -o, will be the Salesforce alias name or org alias name or the username. So we can either give our username here, or we can give the alias name that we set up before. So if you recall, our alias is Salesforce Apex Crash, so I'll use that. And secondly, we need to specify an F argument, F standing for file. So which file would we like to run? So we want to run the file that's within the scripts/apex, and we want to run the examples.apex file. So if I hit enter, let's see what we get. All right, so as you can see here, we're getting a debug log. So let's kind of trace through this debug log a little bit so you guys understand exactly what's going on here. So when I ran this command, it automatically outputted a Salesforce debug log. And it has certain information in here that could be rather helpful in the event that you run into any exceptions, error messages, validation, rule failures, any kind of failure or error that you expected to see in Salesforce. You can come here and read more about it. So going down the line here, we have several different lines that represent lines of execution, debug outputs, specific info or system info. If you scroll down here a little bit more, you have these things here that says like number of SOQL queries, number of SOSL queries. This shows you how many database queries were run in this execution trail. But what we're most concerned with is we want to see the output of hello world, because if you remember, that's what we did initially. So what I'm going to do is I'm just going to hold command and then hit the F key to open up a search bar, and I'm going to type in here hello world. And as you can see, it's right here. So this is our output here, which shows you user_debug, and then line 12 shows this hello world output. So this is working perfectly. So now that was the very first thing that we outputted to a debug log. So that's working great. Excellent. And now that I think about it, there's one more thing I want to show you guys while I'm at it here. So if you're wondering where I'm getting these commands from, there are two ways that you can figure this out. You can look at Salesforce's CLI documentation for some tidbits on exactly what these commands are and how they're used. The other thing you can do, if I just clear this out here, is if you type in SF search, this is going to give you a list of the various commands that the CLI version 2 uses. So as you can see here, right here where my caret is, we have here alias list, which outputs a list of aliases or org aliases, if you will. You also have the ability to set an alias. If we scroll down further here, you can actually create Apex classes with Apex generate class. So there are endless, let me not say endless, but there are definitely lots of commands here to learn. There's no way you'll be able to memorize all of these because there's like hundreds of them. So I think your best bet here is just to kind of look through this documentation. So for example, if I go back up here and let's say I select this one here and I hit enter, you see that we get documentation on how to run this command. And it shows you the various types of arguments that you can use and specify to run this command. Now, when you're in doubt, again, there's plenty of tutorials online. In fact, I'm thinking about creating my own Salesforce DX tutorial for CLI version 2, so stay tuned on that. Just let me know in the comments section if that's something you'd like to see. So I'm just gonna go ahead and clear this terminal again. So let's see, what's the very next thing we're gonna do? So let's go back to writing some code, guys. All right, so now that I show you guys exactly how that works, how we output something to the debug log, one other thing I'll mention here is that if you don't want to view your debug logs within this console, you can actually do it in Salesforce itself. And to do that, you would just log into Salesforce and then go to your setup menu. So you can get to that usually by clicking the gear icon and go and clicking setup. And when it takes you to your setup menu, if you type in debug log in the quick search bar on the left of Salesforce Lightning, and I believe in Classic as well, you'll see the debug logs link. And if you click on that, you'll see all the various debug logs that you've outputted if you've enabled them. Now, I'm not going to go through those steps right now because that's outside of the scope of this course, but just keep in mind that you can actually monitor that easily within Salesforce in itself. All right, now that I explained that, let's get back into some code because I know that's the reason why you guys are here. So we've already outputted hello world. Let's go into variables and data types. So I'm going to create a new method. Within our run method, I'm going to come up here and create a new method called variables and primary data types and close that out with a semicolon. And let's see, let's just save some time here. I'm just going to copy this name. I'm going to come back down here. I'm going to create a new private method, private void, paste that in, and open that up. All right. Now, what we're going to cover right now is variables. We're going to cover variables and data types. So what is a variable? Well, basically a variable is a way for us to store values within our application. It basically allocates some space within the application's memory for us to reference these variables or these values somewhere within our application, whether within the same scope of a method or globally within our application if we're referencing them using attributes or fields. So basically what I'm going to show you guys is the various types of variables that we can use or data types with these variables that we can use. So the very first one I'll show you here is integer. So an integer is a whole number, right? It could be positive or negative. So it could be less than 0, 0, or greater than 0. So an example of that here is, let's say if I want to define the year that a building was built. So I can do that by saying integer and type this, guys, type this within the new method that we created. So we specify first the data type, integer, year built, and let's say that the year that it was built was 1999, and we end that with a semicolon. So basically, What I did is I took the value of 1999, which is a whole number, which represents the year that a piece of construction was built, and we assigned that value to the year built variable. And we're specifying this as an integer to specify the data type. And this is what I meant earlier with strongly typed, because in other programming languages, such as JavaScript, you don't necessarily need to say that this is an integer. You could just say const year built or let year built. But in the case of Apex, we specify the type before the variable so that you know at any time what type of variable this is, which is, in my opinion, a more disciplined way of keeping track of what a value is. All right, so that's basically how we specify what that is. And if we just want to see this really quickly, let's just call this. So I'm going to call my debug function for the first time here. And what I'm going to do is I'm going to pass in a tag, and the tag is going to be just a bit of text to specify what kind of data this is. So in this case, this is going to be year built. You could type anything here, but I'm just going to type in year built, and then I'm going to put a comma after that, and then I'm going to give it the variable name here, year built. So if I go ahead and I run this, and we're going to run this with the same command here, so I'm just going to hit the up arrow, and that's going to be the sfApex run-o, the alias name, and then the file. So if I run that right now, we have a new debug log that was outputted, and if I want to see exactly what the output of this is, let me just type in dash dash dash, because if you remember, that's the prefix of our output, and as you can see here, we see 1999. So let's cover a couple of more numeric data types. So the very next one I'll cover here is long. So let's go here and let's go down to the next line. Let's go down 2 lines and let's define a long variable. And let's create a variable called population. And I'm going to set it to this particular value. And you guys can find the code for this course within the video description. You just click on the source code link for my GitHub repo, and you can clone that repo or export it as a zip file. So that way you guys can have access to this code, or just copy this value from there. So basically what this number is 2,147,483,648. And the reason why we're specifying this value is that a long holds bigger values than integers. And the cutoff for an integer is this value minus 1. So it'll be, the cutoff for an integer is 2,147,483,647. So I'm just going one more than that. So I have to, use a long. And if the number is even larger than this, then we would still use the long to represent a whole number. Now, when you use a long, you need to use a capital L after the value so that Apex knows that this is a long value. It should be handled as a long, and it will be able to sidestep any potential compile errors that can arise. So we declared this value to represent the population of a geographic region. So let's go ahead and output this and see what we get. So I'm going to use that debug custom method that we created, and we're going to call this population. That's going to be the tag, comma, and we're going to pass in this population variable. Cool. So now let me just clear this, and let's use the same command. Just hit the up arrow a couple of times, hit enter. And what we want to do is search for population, and there it is. So now we can see that the population is being outputted, and notice that it is not outputting the L. So the L will never get outputted because remember, this is only going to output the number. It's not going to output any characters like any letters or special characters or anything like that. But in this case, because we're giving it the L at the end, this specifies that this is a long value. So next we'll cover floating point numbers, and what floating point numbers are decimal numbers. They're not whole numbers. So if you think of anything like the price of a bag of apples, or if you think about the temperature, 21.4 for example, those are floating point numbers in Apex. In fact, they're floating point numbers in most programming languages. So there are generally 2 data types in Apex that hold or control the values of floating point numbers. That would be decimal and double. So let's talk about double first. So first I'm going to create a variable called pi, if you remember back to math class. and pi is equal to 3.14. So 3.14, let's say 159. So that's a double. Now, a double is a double-digit precision floating point number. What that means is that you get somewhat precise values out of a double, and generally they're used if you want to be somewhat precise, but you don't necessarily need to be very, very precise. For example, if you're holding values that may have 1, 2, 3, or 4 decimal places, you might want to consider using a double instead of a decimal data type, because you don't really necessarily need to be very, very accurate with the number, because it's a simpler rather floating point number. But when you're dealing with decimals, for example, if you're working at a bank and you've been tasked to write an application to keep track of people's money or their bank account balances, you might want to consider using a decimal data type instead. So for example, a common use case would be the balance of an account. So let's come right under here and let's say decimal, and let's say bank balance. And the bank balance, let's say that this person is fairly wealthy, and so that's their bank account balance. Now, you may be asking, well, why aren't you rounding off to the last 2 decimal places? Well, think of it this way. I guess a better use case example would be the stock market. Let's say you have a share price, and the share price can have multiple decimal places, not just 2. If you need to be very, very precise, you might want to think about using a decimal to be very precise. And if we would have used a double in this situation, it could be that we will have certain inaccuracies in our value because the double is only double-digit precision, whereas a decimal is the most precise decimal value you can get to the T. So that's pretty much what we should use. So in a nutshell, use double if you don't really have many decimal places. Let's say you have anywhere from 1 to 5 decimal places behind, like 1 to 5 numbers after the decimal or to the right of the decimal, and use the decimal data type if you're working with financial data. That's probably the simplest way to do it. That's kind of a general rule of thumb. There may be other use cases in which you can use decimal versus double, but I'm not going to go into that right now. Just keep that in mind that, there's documentation online if you want to know more about that. All right, so let's move on to other data types here. A very common one you'll use is string. And string represents a collection of characters, if you will. So for example, we can define a string of the name of a student. So we can say student name, string student name, and let's say that his name is my name, which is Ron. So as you can see here, I'm basically taking the value of Ron and I'm assigning it to this student name variable. Now Ron is actually surrounded by single quotes. Now in comparison to other programming languages, Apex uses single quotes to specify a string. There is no character data type in Apex, so keep in mind that whenever you want to define a string, you need to use single quotes instead of double. If you use double quotes, then you're going to get an error message. So it's always single for any, and that's a special message for any developers coming from other backgrounds. So yeah, we declared this variable called student name. So let's output that. We're just going to say student name here. And again, you can call it anything you like for the tag. I'm just going to output this student name variable here. Cool. So now I'm going to go back to my terminal here. I'm going to hit up and I'm going to run this. And then I'm going to just search for student name, and there it is. So we have it there, right? Ron is showing here. So actually right there. There we go. Ron. Okay, so yeah, that's working perfectly. And as you can see here, we're outputting this to the console, or rather to the debug log as a string. And guys, notice as I'm doing this, I'm not necessarily converting this data type to anything else. And the reason why this is working is by type coercion, the concept of type coercion in Apex. When you pass a value into the system.debug method call, it automatically stringifies that value so that it can be outputted to the debug console or the debug log. So that's the reason why I don't have to cast the data type, let's say, into a string prior to outputting it, which is pretty neat. All right, so let's go ahead here and let's talk about some other data types here. I guess what I can do next is I can let's go a little bit here into concatenation with strings, which is a common thing you'll work with. So to concatenate a string means to attach, whether you're prepending or appending another string value to the end or the beginning of a string. So here's a common example. Let's say if I define a string of job title, and let's see, let's give it Salesforce developer because that's what we are, or that's what we're becoming here. And then if I want to define another string called company, and let's say the company, maybe let's call it Microsoft. Hint, hint. All right, so we have here this job title string variable and the company variable as well. Now I'm just going to use a regular system.debug here to show you how concatenation works, which is very common in Apex and other programming languages. So let's say, for example, I want to take these values and put them within a sentence, or if I want to just kind of insert them in certain places within a line of text. Here's how I can do it. So what I can do is, let's say, for example, I'm going to say Bobby is and let's say Bobby is a Salesforce developer. So all we need to do is just within the string, we're going to have our single quotes and say Bobby is and make sure you format this properly so it looks good. We're going to use a plus sign, and that represents the concatenation operation. So that's basically going to attach anything behind this to the prior string. So what we're going to do is insert the job title here. So basically that's going to read Bobby is a Salesforce developer, and then we're going to use another plus sign. We're going to open up another set of single quotes, and we're going to put a dot here. That's the end of the first sentence. And then next we're going to say he works for, and now we're going to concatenate the company name. So let's see how that looks if we've got that correct. I'm going to go back down here, hit the up arrow and enter. And let's just look for Bobby here. B-O-B-B. There we go. So basically that's what it is here. So we have it here, as you can see. Bobby is a Salesforce developer, and he works for Microsoft. So that's working perfectly, all right? So that's basically how you do string concatenation. Very simple. You just use the plus operator to attach, whether you're appending or prepending a text or an integer or any other data type within a string. Now keep in mind, in most cases, if you're using other data types and you want to concatenate other data types to the string, you'll need to actually cast that data type to a string. So you would do that using the string.valueof function, okay? All right, so let's go ahead and move on here. I guess what I could do is I'll show you an example of type casting just so it's clear to you guys here. So let's say if I define an integer, I'm going to define an integer of just num. And let's set that integer to 40, okay? So I'm just defining a simple integer called num and setting that to 40. Now I'm going to create another string variable, and what I'm going to do is I'm going to cast this or convert this integer to a string. So let's call this num as string. And here's what I mean here. What we want to do to convert this to a string is within the string class in Apex, we have a value of method. So we're going to say string.valueof, and we're just going to give it the integer above, the num integer. So that's basically passing in the integer data type of num, or the num, which is an integer data type, into this string value of method. And that's going to automatically convert this number into a string. So now let's output this. And again, I didn't need to do this to debug this. Like, I didn't really need to cast it, but I just want to show you that we're not going to get any error messages. And this is generally how you would convert a data type to a string. So I'm going to just say here, number as string, comma, and then I'm going to just pass in number as string and semicolon. So let's go back down here, hit the up arrow, and what we want to do here in our search is we want to look for number as string, and there we are. The 40 is being outputted, and this 40 is not currently an integer. You may not notice the difference, but basically this is a string. So if you were to try to run a math operation on it, nothing would happen. basically it would not calculate a new value. It would just be pretty much concatenated to this string. So yeah, just keep that in mind that even though it looks like a number, it's really a string. Okay, let's move on. So now we have other data types that we can work with within Apex. So another one is called Boolean. And Boolean can be a true or false value. So I'm going to define a Boolean variable called is student. And I'm going to set that to, let's say we'll set that to true. So basically that's how we declare a Boolean variable. We just give it a true or a false value to say that this person is a student. We believe that they are, so we're going to set that to true. Let me just output this and see what we see. So debug, I'm going to say is a student here, and I'm going to pass in the is student variable. So I'm going to come back down here, hit the up arrow, enter. Let's see what we get. Let's search for is a student, and here we are. So as you can see, we're outputting true, and this is outputting a Boolean, okay? So being that it's coerced within this is being pretty much casted under the hood within the system.debug method, but it's still a Boolean value that we're passing to the method. So I just wanted to show you what that looks like here. The opposite of true obviously is false, right? So if we were to convert that, if we were to change that to a false, it would output false. All right. Now I'm going to show you guys later exactly how we use that, because right now it really doesn't mean anything. Like you're looking at this and you're saying, well, how could we use this? And we're definitely going to get into a more advanced topic later on, which is control flow statements, and you'll see exactly how Booleans are being used. All right. So another important data type specifically in Apex is called blob. Okay. And what the blob does is generally used to store binary data. So a common example would be, for example, in Salesforce, you may have a file that's an attachment, and the actual contents of that file is not maybe, for example, an image or the actual text. The actual context is a series of zeros and ones, which represents binary data. So we need to store that data within a blob variable, so that way we can parse through that data and, for instance, store a file in Salesforce via an API call. We're not going to go into the API part, but let me show you what a blob does. So I'm going to define a new variable called binary data. And in this variable, let's see, I'm going to call a class called encoding utils, which is a built-in class, encoding util rather, and that's within the Apex framework. And we're going to call a method called base64 encode, which is automatically being suggested here. Actually, you know what? Let's do base64 decode. Now, what these are, the base64 encode is if you want to take any kind of information or data and encode it in a base64 binary format, so that it can be transmitted via API, for example, or it can be stored to a file. Whereas a base64 decode is when you do the opposite, where you take in specific kinds of file information and you decode it into a blob or binary data. So in this case, you can see that it's asking for an argument. And what we're going to do, we're just going to give it a simple string here. So we're going to say base64 data, okay? Base64 data, and we're going to add a semicolon. Now, in a real world scenario, you may be using other types of data, but I'm just going to show you what this does here. So I'm going to output this. I'm going to output binary data. And then after that, I'm going to pass in this binary data variable. So let's see what we get here. Let's go back down here. Let's run this. And let's do a search for binary data. All right, so as you guys can see here, we have this blob of 7. What this means is that this created somewhat of a blob. I don't want to say array, but it's sort of a blob kind of collection, which contains 7 bits of binary data information within it. And generally what we would use in a real world scenario, what we would use this for is to store this binary data in Salesforce, for example, to represent a file or some sort of attachment within Salesforce. So, generally that's all you can see, and that's mainly for, for brevity and security reasons, you won't be able to see what's within this blob just by using a simple system.debug output. But in most cases, you would not do it that way anyway. You would actually store it in a file or store it to like a specific object in Salesforce. So that's what a blob is used for. It's not used very commonly. Again, it's mostly used if you're dealing with file data. All right, so let's move on here. Let's see, what do we need to still cover here? I guess we can also cover exactly how we declare variables besides what we've been doing. There's another way to declare a variable. We can actually just declare it without instantiating it or without initializing it rather. So for example, I'll give you a common example. Let's say that we just want to specify a new variable, create a new variable, but we don't know the value of what we want to create at the time that we declare it. So for example, let's say we want to track the quantity of inventory. So we could say integer quantity, but normally we would say integer quantity is 10, for example. But let's say we don't know the value. We could just simply do this. And doing that will allow us within the scope of this method to actually set a value to quantity anywhere further down the execution chain. So now let's say somewhere down the line, you know what the quantity should be. So we can now down here say quantity is equal to 3, for example. And that basically will set now the value of quantity to an integer data type of 3. So now let's output this just to show you that there are no error messages. We're going to just say quantity, and we're going to pass in quantity here. All right, so let's go back to our terminal and run the same command again, this sfApex run. And let's look for quantity. Where are you? Oops. So looking for quantity here. Quantity, I'm not seeing it. There it is. Okay, so we have a quantity of 3. There we go. So as you guys can see, it still works. Now, what's the most common way, you ask? Rule of thumb, initialize your variables as you declare them, which means integer quantity equals 10 is better, in my opinion, than just integer quantity semicolon. You generally would not do what we're doing right here. Like, you wouldn't break this up into 2 lines normally. You would only do this in the event that you don't know what the value of something should be until later on in the execution trail. So just kind of initialize your variables in the same line as you declare a new variable. That's the best practice. All right, let's move on a little bit further here. Now, we also can work with dates and date times within Apex to just signify what a time period looks like, or a specific date should represent in Apex. So the very first one I'll cover here is date. So let's say I want to define a new date. We can use the date data type, and we're going to call this variable my date. And in this variable, we're going to say date, and we're going to create a new instance. So that gave us some auto suggest here. We're just going to add a semicolon. I'm just going to get rid of these arguments, and I'll go one by one. So this new instance method of the date class, which is a built-in class within Apex, takes several arguments. The very first argument it takes is the year. So we're going to give it 2023 for the year. We're going to give it October or 10 for the 10th month of the year, which is October. That's the second argument. And we're going to give it the 14th, which is the 14th day of October. Okay, so basically we're creating a new date object, and that date object is October 14th, 2023. Now, also we can work with date time. And date time, the difference between date and date time is that the date time is basically date with the time added on to the end of it. So I'm going to create a new date time variable, and I'm going to say my date time. That's the name of the variable. And basically what we want to do here is we want to use the date time class, and we're going to also call the new instance method. Now this new instance method takes a few more arguments. What we want to do is let's create the same thing we did above here. So we're going to say 2023 October 14th, but beyond that, let's say we want to give it a time. So let's say we'll give it 3:30 p.m. So 15th hour. So to find out, because this is based on a 24-hour clock, So if you think of like military time or European time, that's what this is based on. So what you want to do is just kind of like look at this number as subtract 12 from it to get 3 if you're based, let's say, in North America. So we want the 15th hour, which is 3 p.m., and then 30 to represent the minutes. So that will be 3:30 p.m. so far. And then what we want to do is give it 0 to represent the seconds. So now we basically created a new date time object, which basically represents October 14, 2023 at 3:30 p.m. So let's go ahead and output these. Let's see what this looks like. First, we're going to output the date. We're just going to pass in my date. And let's output date time. And this is going to be my date time. If I could type, oops, my date time. There we go. All right, so let's go back down here to our terminal. Let's run this command again. And let's see if we notice any differences between the two. So if I look here for date, there we have our date. So the very first thing you'll notice when comparing date and date time is the very first line up here, the date line. You'll notice that we have our date, which, and by the way, this is being outputted based on the current locale of the user. Now, as of the moment, I'm based in Europe, so it's outputting this as sort of like how Europeans typically would output a date in this format based on my locale. So then it's outputting the date, and then it's outputting the time as 00:00:00. This is for the date object, and that's basically saying 12 midnight, 12 a.m. midnight. Now, why is that happening? That's happening because we didn't specify a time element to this date because we use a date data type. And basically, in this case, if you wanted to sort of get rid of this, you would then do like some string manipulation. You would convert this to a string and then chop this off, or you could probably cast it to a different type and then, remove this altogether. But, generally Salesforce would ignore this, this 00 value here because it knows that it's a date type. But if you look at the date time type below, you can see here that we have a date time representation here. Now, you may be asking yourself, well, why does it say 1930 instead of 1530? Well, even though we specify 1530 above, that's because this is represented in UTC time, right? And based on my current time zone, it's outputting it based on my locale for my time zone. It's outputting it as 1930. So you want to be careful when you specify a time value as part of your date time. There is also a time data type in Salesforce, so you have to kind of be careful of times as well, making sure that you're casting it correctly. Let me give you an example of time while we're at it. So let's go down here. Let's define a new time using the time keyword here. And we're going to just say the current time. We want to create, we want to output the current time to the debug log. So we're going to say the current time, and we have a method called now, which is part of the system class in Salesforce. So all we need to do is say system.now. And all we want to do here is we just want to output the time. So I'm just going to chain a method call of time to the end of now. So it's system.now.time, which will give us the current time. So if I output this in the debug log, so we're going to say current time and pass in current time. And let's go back down here and output that. Let's run the code. Time, then we have the current time. And again, as you can see here, the current time is based on my locale, pretty much the values that I give, right? So keep in mind that if you want to convert based on time zones, you need to have the proper logic in place. Now, we're not going to cover time zone conversion in this course, but there's plenty of tutorials of how to do that in Salesforce. All right, so I guess let's move on to object data type. Now, if you guys remember up top, let's just scroll back up here. Up top here in this debug function or debug method that we defined, we're passing in a second argument of a data type object. And the object is basically the topmost class in the Apex framework that represents any type of data that we're dealing with, because an object can represent an integer. It can represent a more complex object like a custom or a standard object like a count. It can represent anything. Well, generally, when we're talking about Salesforce objects, instead of using object, you could use S object, but you can also use an object and cast it to an S object as well. Now, that's going outside the scope of what I'm trying to explain here, but in a nutshell, generally what I want to show you is how object works. So let's kind of go back down here and create some space here. And the first thing I'm going to do is I'm going to type object, and I'm just going to define a new variable called obj, or that represents object, and that's going to be a string. So we're going to say obj equals Tommy, which is a string. Now notice we're not getting any error messages, and the reason why is that a string is an object, and because a string is an object, it's allowing this because the object is a parent class of the string class in Apex. So that's the reason why we're not seeing any error messages. So now we gave it a value of Tommy. Let's create a string variable. Let's say string, and we're going to say obj value. And this obj value, we're going to cast this object to a concrete string. So we're going to say string.value of again, and we're going to pass in this object. And again, no error messages, no compile messages or anything like that. Let's output this and make sure we get no runtime errors. So I'm going to just pass in here, let's just say object value, and we're going to pass in object value like that. Now, what I'm expecting to get back is Tommy. So let's see if that works. So I'm going to run this. I'm going to look for object value, and there we have it, Tommy. So why did that work? That worked again because a string is an object. So everything is pretty much an object in Apex programming. And because a string is an object, and because we're referencing an object data type, then it's basically allowing us to specify any kind of data type here and store it in an object variable, okay? Object data type or variable of the object data type, if you will. That's the reason why that works. If you kind of think about it in an inheritance model, which is a common object-oriented programming concept, basically your child, if you have children, is a reflection of you. So a string is a reflection of an object, and that's the reason why this works perfectly. Now, why would we do this? A common use case scenario, again, is if you don't really know what a particular data type is of a certain value. Let's say you're pulling information from an API or from a database and you're not really sure what kind of data type it is, you might want to store it as an object and then somewhere down the line use the type of, or rather instance of, keyword to just check to see what kind of data type it is. And then based on the data type it is, you might want to do certain things like save to database, for example, or you might want to run a calculation if it's an integer or a floating point number. Whatever you want to do, it's within your grasp. So, that's generally what you would use, or what you would do rather, when you're using the object data type. All right, I think we covered mostly everything we needed to cover with variables and data types here. Or primary data types. So good. So now let's move on a little bit further. I think I explained quite a bit in detail here. The very first thing we want to do, or the very next thing rather, is we want to cover math operators. So I'm going to go back up to my run method, and I'm going to create a new method called math operators. One thing I want to point out here is, as I'm calling these methods, obviously we need to define them below, because just specifying math operators like this, and if I were to run this, we're going to get an error message because math operators does not exist, right? This method has not been defined. So generally, you want to just make sure you define every single method that you're calling. The other thing I'll point out here is, in a real world application, we would never really just say math operators as the method name. We would have a method name, for example, such as run math operators. And so generally, as a rule of thumb, we would start the method call with a verb instead of with a noun. The reason why I'm doing this is for brevity. So just keep that in mind. This is not the best practice, but for brevity and just for you to understand fully what's going on, I'm just calling the methods like this. All right, so we're going to create a math operators method. So let's go ahead and let's copy that name, and let's go all the way back down here. We're going to define another private method. So private void and math operators. Now, what are math operators? So math operators allow us to run calculations. We can do addition, subtraction, multiplication, and division. And we can also figure out what the remainder of a division operation is with math operators. So what I'm going to do here is I'm going to give you a few examples of how to do each of these. So the very first thing I'll do, let's add a couple of numbers together. Let's create two integers. Let's say integer num1 is equal to 10 and integer num2 is equal to 5. So the very first operation I'll demonstrate here is addition. So the next thing we'll do here is we'll output the sum. So integer sum is equal to a plus b. Actually, not a plus b, num1 plus num2. And let's just output this. Let's do it here, debug, and say sum. And we're going to just output the sum here. All right, so let's come back down here. Let's run this. All right, and let's search for sum. And as you can see here, we have the sum, which is 15. So that's working. It's that simple. All right, so now subtraction. So if we want to find out the difference, we can say int diff is num1 minus num2. We're going to say debug difference, and we're just going to pass in this diff variable. Cool. So let's run this down here, and let's look for difference. So type in here diff, and here we go. We have it. So now one thing I want to point out here is that we have a difference of 5. What if we subtracted 10 from 5? So let's go back up here, for example. I'm just going to demonstrate this to you guys so you can see exactly what happens. So it said, let's make num1 5 and num2 10. So now we're subtracting 10 from 5. Now we expect to see a negative number, so let's just make sure that works. So I'm going to go ahead and run this again, and let's just see what our difference looks like. Obviously, our sum will be the same because it doesn't matter because we're doing an addition, but our subtraction operation will return to us -5, as you see here. So -5. And obviously the reason why that's happening is because we're subtracting 10 from 5. So let's go ahead and reverse that. Let's just make that 10 again, and let's make that 5. I just wanted to show you that we can store negative numbers in integers as well. And then obviously the same rules will apply for longs, right? So if we have a long longer than that 2.14 billion number that we saw earlier, if it's a negative number, we want to store that as a long as well because we have that range on the negative and the positive sides. All right, so the next thing I'll show you is multiplication. So let's say we want to show the product, which is the result of multiplying two numbers. So we're going to say the product of num1 and num2. And we're going to output this as product and then product. And while I'm at it, just for brevity, I'm going to also do the quotient, so dividing two numbers. So give me the quotient of num1 divided by num2. So multiplication, you would use the asterisk key or the asterisk sign as you see above here. We're doing num1 asterisk num2. And for the division, you just use a /. That's the operator. All right, so then we're just going to output this quotient like this. All right, so now let's go ahead and run these and see what happens. So the very first thing we want to look at is what is our product. And here we have it here. So our product, when you multiply them together, our product equals 50. So 10 multiplied by 5 is 50, and then our division result, which is our quotient, 5 divided by 10, or 5 into 10, is equal to 2. So everything is working, and that's basically how you would use math operators. Now there is one more I want to show you guys. What if we want to know what the remainder is after a division result? So we basically want to find out how much is left over after the fact. All right, so what that is called is modulus in computer programming. So we want to find out what the modulus is of two numbers. Now to do this, to demonstrate this, I'm just going to kind of define some new variables here. So the first one here, we're going to just define an integer variable of num3, which is equal to 24, let's say. And we're going to create a new variable called remainder, right? And this is going to store basically the remaining value after the division operation has run. So we're going to set that to math. We have a class called math in Apex, which has a method called mod. And as you can see here in my auto suggest, it takes in two arguments, x and y. So I'm just going to go ahead and select that. Now the x value, it doesn't matter which order you put this in for the most part. Actually, it would matter in some cases, so I would say be careful. But for the most part, what we're going to do is we're just going to pass it in like this. We're going to say num3, that's going to be the new variable value, and we're going to use the num1 value. So if you recall, the num1 value is 10, the num3 value is 24. So based on that, if we do that division, we would expect a remainder of 4, because we're basically dividing as much as it can go into 20. So 10 goes into 22 times, so that would be 2, and then we will have a remainder of 4. That's what we're expecting here, okay? So let's just see if we're right. So we're going to output modulus or / remainder, okay? And we're just going to output the remainder here, all right? So let's come back here, let's hit the up arrow, run this, and in our search, we're going to look for modulus. And there we go. We get a remainder of 4, as you can see right here. So that's working. Very powerful if you think about it, because we don't have to care about the inner workings of how to get the remainder. It's handled for us with the math class. All right, so that pretty much summarizes math operators. Let's move on a little bit more quickly here to get to some other concepts. So I'm going to scroll back up to the top here. I think the next thing we're going to cover is comparison operators. So let's create a new method called comparison operators in our run method. Comparison operators. And I'm just going to copy that name, and I'm going to come back down here, and I'm going to create a new private void method, comparison operators. So what are comparison operators now? So comparison operators allow us to compare two or more values to one another to make a determination, to control the flow of an application. So here are some examples that I can give you. It's best to show through an example. So let's say I wanted to find a new integer variable. So let's say int a, we're going to keep things simple, that's equal to 10 again, and then integer b is equal to 5. I like to make things nice and simple, so we'll just use the same value so you can clearly see what's happening. Now, with a comparison operator, typically you'll have a true or false condition that needs to be met in order for you to determine what logic to run next. And if you guys recall, the Boolean data type stores true or false values. So what I'm going to do is I'm going to create a new Boolean variable called is equal. And basically what we want to do is we want to see if these two numbers are equal to each other in value. So we're going to say if A double equal sign B and semicolon. So the single equal sign will assign a value to a variable. The double equal sign in most programming languages will check for equality between two values. So that's what we're doing here. And so in Apex, we're using the double equal to check for the equality of two values. So let's output this and see what we get. We're going to output our numbers equal, and let's just pass in the is equal. Now, if these numbers are equal, it's going to return true because again, this is a Boolean. If these numbers are not equal, for example, if one of them is 1 and the other one is 4, it's going to return false. Now, in this case, A is 10 and B is 5, so we know that is equal should be false, right? So let's make sure that that's correct. I'm going to clear this output, run this code again here, or this command rather. Come back to my search and look for R numbers equal. Here we go. And as you can see, it returns false. And the reason why is because 10 is not equal to 5. So that's working. All right. So now what if we want to check if two numbers are not equal? Let's create another Boolean, is not equal. Okay. Now these two numbers are not equal, right? Obviously. So we're just going to check if A, exclamation mark, equal sign, B. So basically, if A is not equal to B, so we expect this to return true in this case. So again, our numbers not equal. So again, we want to check for inequality here. So we're just going to pass in is not equal, and we expect this to return true. So let's come back down to our console and rerun our debug log again. And search for it, our numbers not equal. There we go. Here we have it, true. So again, this is true because 10 is not equal to 5. So far you guys are starting to see exactly how we can use some of these Boolean data types or Boolean data type to sort of understand if two values are equal or not. So we got a lot more. So let's say, for example, if we want to check if one value is greater than another. So we can define another Boolean called is greater, and we're going to say if A is greater than B. If you guys remember back to math class, the greater than sign is represented with this right bracket or this right angle bracket, and then the less than is represented by a left angle bracket. So in this case, we want to just say if A is greater than B. Let's output this. And obviously, we expect this to be true because 10 is greater than 5. So is A greater than B? We're just going to pass in is greater. All right, save. And let's go ahead and run that again. And let's search for is greater. Okay, did I misspell something? I think I did. Is greater. Wait. Oh, is A, I'm sorry. So is A greater than. There we go. So here we are. It's true because 10 is greater than 5. So what I'm going to do here is I'm just going to kind of go down the line quickly and write out all of these, and we'll just output them one by one. So the next thing we want to do is check for is a number less than, as we know before. Now, there are two ways we can check if is less than. We can simply just invert this up here because we're checking for is greater. So a little trick is if you want to check if it's not, then you could just put parentheses around this A greater than B and just use an exclamation mark in front to invert it. But that can cause problems if you're not careful. So the better way to do that is just to use the operator. So let's just say Boolean is less, and then we're going to say if A is less than B by using the left angle bracket. All right, and then that pretty much represents is less than. And as I said, I'm just going to kind of go down the line here. If we want to check if a number is greater than or equal to, let's say is greater than or equal, we can say if A is greater than or equal to B, like that. So right angle bracket and equal sign. All right. If we want to say if a number is less than, so is less than or equal, is equal, we can say A less than, so left angle bracket, and then equal B. All right. So that's basically how we can, let's just output these right now to see what this looks like here. So what's the other one? So we want to do is less than, so we can say less than, and we're going to say, let's say is less, So that's the one above here. And then we're going to do output this one. We can say greater than or equal to is greater than is greater. I think it's just is greater. Yep, is greater or equal. And then this one here is less than or equal to is less or equal. There we go. All right, so let's see what these outputs look like here. So let's go down here and run this again. And we're going to first search for less than. All right, so as you can see here, we have false for less than. So basically 10 is not less than 5, so that is false, and that's exactly what we expected. And then next up we have here is greater than or equal to. So 10 is greater than 5, so that is immediately true. If 10 were equal to 5, or let's just say we had two numbers that were equal to one another, that would have also returned true. But in this case, we short-circuited because it is greater than 5. The next output here is less than or equal to. That returned false because 10 is not less than 5 and it's not equal to 5. So these are working perfectly. And as you can imagine, you can use a lot of these to create very, very powerful logic within your application and sort of control how things happen, when things occur, and on what basis they occur. So yeah, that pretty much covers comparison operators. Let's move on here. So let's scroll back up to the top and let's see. I guess the next thing I'll show you logically are logical operators, okay? So basically, let's create a new method call here. I guess we can call it logical operators. Cool. Now, what are logical operators? So basically, I can demonstrate for you, but basically they help to control the flow of the application. So you have like scenarios like the AND operator where you can pretty much evaluate two different sets of logic within, and if both sets of logic are true, then you can execute a certain block of code, for example. You have an OR, which basically says either this or another condition must be true in order for me to execute something. So let me just demonstrate. Let's create a new method down here, private void logical operators, and open that up, okay? Now, with logical operators, again, we want to be able to control the flow, and we can use this in conjunction with comparison operators often to really make dynamic applications. So here, let's say, let's create a couple of Boolean variables here to get started. So I'm going to create a Boolean. I'm going to say Boolean x to make it simple is equal to true. And then another Boolean variable, which is y, is equal to false. And then down here, we're going to check to see what happens if we use the AND operator. So I'm going to say Boolean AND result x double AND sign y. Now, what does this mean? Excuse me. So basically what this means is if x is true and if y is true, whatever the condition of y is, then if both of these are true, return true. If any of these or either of these are false, then return false. So a more real world example here is if you think of, for example, let's say if you have a variable, a Boolean is sunny, and then you have another Boolean will go out on weekend, for example. If either of these would be false, then basically the end result would be false. So let me show you how this works. Let me just output this. I guess that's the best way to show you. I'm going to output this. I'm going to just say AND result and pass in the AND result variable. And you'll see exactly what I mean. Now again, keep in mind that one of these are false. So let me just clear out this output and just run this again. And if I search for AND result, you see here it's false. Why? Because y is false, right? If y were true, and I'm going to show you exactly what I mean right now, if I were to change y to true and rerun this, then I'm expecting a true output. So run this again here, and now you see that it's true, and the reason why is because both values are true. So we use the AND operator, the AND logical operator, because we want to check that both values are true. If this value, if y is false, like what we had before, y is false, basically this will short circuit this evaluation, which means that if if x is false, I meant to say, let me just correct that. Say if x is false and y is true, for instance, when Apex runs this evaluation and it finds a false here, and we're basically counting on it being true, but it's false, Apex will automatically short circuit this evaluation to save system resources. So it will exit out of this evaluation, it'll just ignore it and keep executing further lines of code. And that's basically a concept called short circuiting, which is found in many object-oriented programming languages. So the very first operator must be true in order for the evaluation to continue here. So what I'm going to do is let me just flip this x back to true and this y back to false, and hopefully that made sense what I was trying to say. You might want to look up further information because this same concept is used across many programming languages. Next up, I'm going to show you what happens if we are counting on either of these to be true. So we're going to call this OR result, and we're going to say x or y. So basically what this is doing here is we're saying if x is true, do something. Otherwise, if x is false, check what y is. If y is true, do something. This again is short-circuiting. If x is, this is not short-circuiting, rather, this is actually going to evaluate the second argument. So if x is false, it's going to go on to the second argument and check for y to be true. And if y is true, it'll basically return true. If y is false, it'll return false. So let me show you exactly what happens here. Let's just debug or result here. Let me come back down here. Here, and run this command. All right, and let's check for OR results, and there we have it. So as you guys can see, it's returning true. Why? Because x is true. If we were to flip x to false and leave y as false, it would return false. And if we were to flip y to true, where x is false, it would return true because y would be true, right? So you got to kind of think of a scenario where if you want either of these values to run a certain line of code or a certain block of execution or lines of code, you want to check for check for whether one of these values are true. You can combine these with some of the operators we've already covered to create more extensive logic and conditional statements that we can use to control the flow of the application. So yeah, there's many things you can do with and or. Now there are others for sure. For example, we also have a not operator. And let me show you how that works. So let's say, for example, we already know that y is true. Let's say if we want to invert that value. So we're going to say Boolean not result is equal to exclamation mark x. So what this will do is this will take whatever the value of x is, whatever the Boolean value of x is, and invert it to make it the opposite. In this case, x is true. So it will invert true to false. So let's output this and see if that works. We're going to say not result, and we're going to output not result. And save. Make sure you always save. I should have said that earlier, but let's go ahead and run this command. And let's check for not result. As you can see here, it's false. Okay. And the reason why it's false is because we're inverting true to into false. So a common scenario for that would be, for example, if you have a toggler, or if you have like a situation where a value needs to be toggled between true and false based on a certain condition. Instead of saying, instead of defining it like x is equal to false like this, you could just simply invert the true value if you know that it's true, and by using the exclamation mark, which means not. If it's not true, basically, then it's false, right? So that makes sense. One common thing that I've done when I first started learning how to code is I talk to myself often, and talking to myself may seem strange, awkward, but when you do that, it makes common sense. If you just speak it out in English or whatever your native tongue is, and you just say it aloud to yourself, then you start to understand more about, how coding works, and it just makes logical sense when you say it to yourself like that. I don't have to do that anymore, so thankfully people don't think I'm crazy, but yeah, that's generally what I did initially when I started my career. All right, so we're pretty much done with logical operators. I think we're fine there. Let's move on to a couple more advanced topics. Let's cover next conditional statements. And this is pretty much going to be the bread and butter of many of your applications. You're pretty much going to be writing a lot of conditionals. So we're going to say conditional statements in our run method above. Perfect. To just define that. And then we're going to come down here. Private void, paste in that. Cool. Now, conditional statements allow us to control the flow of an application by using the if keyword or the switch keyword. And I'm going to show you a couple of examples here. These are very common keywords that you would use in programming in many languages, but in the case of Apex, we use this to control the flow and the logic within the application to make the application do something based on a given condition. So for example, let's define a new integer variable because we love numbers called age, and we set that to 25. So age is equal to 25. One thing that we can do here is let's check what we want to do is we basically want to output a specific message to the debug log based on the current value of age. So for example, if age, we use the if keyword to check if a certain condition is true. So we want to say if parentheses age is less than 18. So for instance, if this person is under the age of 18, what we want to do is we're going to say system.debug. We're just going to do a standard debug here. We're not going to use the debug custom method. System.debug, you are a minor. All right, so this person's a minor if they're under 18. Now, we also have something called else if. But first, what I'm going to do is I'm going to define else. And else is basically going to be the ending trail of our if-else chain. All right, so the else block here will be pretty much the catch-all scenario. If the if is false, so if the age is over 18 years old, then that block will be ignored and it will automatically jump to this else block. So let's output here else system.debug. What do we want to say? Let's just say for now, you are a senior citizen. A little bit assumptive, but let's just imagine that this person is a senior citizen. All right. All right, so with that being said, so what I'm going to do here is I'm going to run this and let's see what kind of output we get. All right, so what is outputting here is you are a senior citizen. And the reason why that's being outputted is because age is currently equal to 25, so it's over 18. So you are a senior citizen. Now, obviously, that's not a realistic scenario because a person could be under the age of 65 and over the age of 18 and not be a senior citizen. So how do we account for that scenario? That's simple. We just add an else if chain. So let's come down here. Let's move this else block down. And on line 127, I'm going to add else if, opening, closing parentheses, and let me just open and close the brackets. And what I'll do is I'll move this else block back up here like that. So this else if condition will need to check if the person's age is over, is between 18 and 65. Because if the person is between the ages of 18 and 65, we can assume that they're just an adult. They're not a senior citizen. They're just a general adult, a basic adult. So we're going to say else if age, and here's where we use some of those operators, is greater than or equal to 18. And now we're going to use the logical operator of the double ampersand operator. And if the age is less than or equal to 65, then this person is just an adult. So we're assuming here that this person must be 66 and up to be considered a senior citizen. So we're going to just system.debug, and we're going to just say here, you are an adult. All right. So let's run this and make sure this works. I'm just going to completely clear this out and run this here like that. And let's see, you are a, here we go. So as you can see here, it's outputting you are an adult. And why is that happening? Well, it's basically outputting you are an adult because of the fact that the age is currently set to 25. And basically, because the age is between 18 and 65, is outputting you are an adult. If I were to change this age to 17, or let's just say 16, and I rerun this, let's see what we get here. You are, yep, you are a minor, as you see here. Awesome. And if I were to change this, let's say, to 100 years old, and rerun this, you are, where is it? There we go. You are a senior citizen. So as you guys can see, this is very powerful because we can now control what happens. Another real world scenario here is if you want to do a certain thing, for example, you want to write to a database some data, or if you want to call an API route, but you only want to do it based on a certain time of day, or you want to do it based on a certain numeric value or string value, you can simply just use an if else block, or just an if else block, or just an if block, because you can actually use if by itself. You don't need to always have an else. But a common scenario is, or a common best practice is, to use an else because you want to be able to catch the scenario, catch the kind of like the out of bounds scenarios that could happen throughout the course of an application execution trail. So that's basically how the if, else if, and else block works. Now, Apex not too long ago also added a new construct called switch. It's called switch when. Now, the difference between an if and else and a switch is that a switch will basically take in a certain condition, and then you would just literally and explicitly output that condition within a chain of execution. Let me just show you what I mean. So let's say, for example, let's see, what can we do? Let's say that we want to work with the days of the week. So I'm going to create a new integer variable, call it day of week. Okay, and I'm going to set that to 3. So basically Wednesday, because we'll assume that Monday is day 1, right? So Monday, day 1, Tuesday, day 2, Wednesday, day 3. All right, so then the next variable I'll create, I'll just declare a variable of day name, and I won't set a value to it. Cool. And now what I want to do is, based on the day of the week that it is, I want to assign the name of the day to the day name variable and output that to the console. So what I'll do here is I'll type in here switch on, and then basically what we want to switch on is the day of the week, right? We want to switch on the day of the week. So the day of the week will be the argument that we're passing into the switch when statement. So now we have to define our whens. So we're going to say when, and we're going to open up curly braces here. So we're going to say when the value of day of week is 1, then we want to assign a day name. So we're going to say day name is equal to Monday, semicolon. So again, going back up here, we have our switch on. We're passing in day of week, which is the numeric value of the day of the week that it is. And our first case, or our first condition we're checking for, is that the value of day of week is 1. If it is 1, this is basically like saying if the value of day of week is equal to 1, then we assign the value, the string value of Monday to this day name. So then we just can't pretty much go down the line. So what we can do here, let me just copy this block of code, and we're going to paste this in here, and we're going to say when 2, then we can pretty much assume that it's Tuesday. Did I spell that correctly? Forgot my D. And we'll paste this in again below, and we're going to say when 3, and this obviously will be the block of code that would execute. We're going to say that it's Wednesday. We're going to paste it in again, and we're going to say when day is 4, we're going to say Thursday, and then paste it in one more time. When 5, we're going to say it's Friday. Okay. Now, we haven't covered all the scenarios yet because we also have Saturday and Sunday to take care of. Now, we could just simply say, you know, when 6, when 7, but let's assume that we haven't defined that somewhere in our application. Let's assume that nowhere in our database, nowhere is it hard-coded that there's a value of 6 or 7 that represents the day of the week. So to handle these catch-all scenarios, we can actually specify a when else block. So we can say when else, and this is going to be the catch-all. If none of these conditions above are true, it's going to fall into this block of code, and then we can just simply do system.debug in this scenario, and we can say it's the weekend, or we'll just say weekend. Okay, so it's either a Saturday or a Sunday, and that will be the catch-all scenario here. All right. So now what we want to do is we just want to output this. Now I just want to make sure my curly braces are fine. I think it would be after this one. So let's just output this value here. So what we want to do is output the day name. So day name, day name. So in this case, kind of scrolling back up here, we know that our day of week is equal to 3. So we're expecting that once this code executes, it's going to hit this when 3 block right here, and it's going to assign Wednesday to the day name variable. All right, so I'm going to just go ahead and save that, and I'm going to come down here and run our command again. And I'm just going to search for -- day name. And as you guys can see right here, we have a day name of Wednesday. And again, the reason why is because our day of week value above is equal to 3. So let's change this just to make sure this is working. I'm going to set that to 1 now. So now I'm expecting this to say Monday. So let me go ahead and run this command again. And when we run that, we see that we get Monday. I just want to make sure I had the right debug log. So we see right here we get Monday now because day of week is equal to 1. All right. Let me completely clear this console here. And let me now give a completely different value outside of these. So as you remember, we don't have a 6 or 7th value. So I'm just going to set this to 6, let's say, for example. So like Saturday. But again, we haven't defined this anywhere in our code. So we're expecting this to show us weekend. So let's go ahead and run this again. So upon running this, let's do a search for just weekend. And there we go. We have weekend right here. And the reason why we're getting that is, again, it's going through all these blocks of code and it's not finding any match. And then when it gets down to this when else, then it just outputs weekend using the system.debug method call. So that's pretty much what a switch on when statement looks like. This is comparable to the switch case statement that you'll find in other programming languages. It's just that Salesforce chose to name it something different because we have a case object in Salesforce and it wanted to avoid conflicts with that object, which makes perfect sense. Okay, so that's pretty much how that works there. That's how conditional statements work. They are also referred to as control flow statements. And that's basically how we can control the logic. So these 3 things together the conditional statements, logical operators, and comparison operators, and even math operators to some degree can be used cohesively and in conjunction with one another to create a very powerful application in terms of the amount of logic, and the difficulty or complexity of the logic can be controlled with the if-else statements or the switch on when statements. All right, so let's move away from the logic piece for a second here. Let's continue on with data structures. So I want to talk about the various data structures that we have in Apex programming. So the very first one we'll cover here is arrays. So let's just type in arrays up here in our run method to create a method called arrays. And then whatever we type up here, of course, we have to come back down here and we have to define a brand new method. So we're going to create a private void arrays method down here. All right, so what are arrays? So arrays are basically data structures that hold a series of values of the same data type. So if you think of an array sort of as a box, let's say you have a box and you're moving. In that box, you may put various types of kitchenware in that box, like pots and pans. Even though they may look slightly different, they're still in the category of kitchenware. So if you think of an array sort of as a box that holds multiple items of the same data type, that's basically what arrays are, right? And we use them so that way we can quickly group certain identical items or similar items together. So let me show you through an example, as that's the best way to show you. All right, so the very first thing here is I'm going to create an integer array. So this is going to be an array of numbers. So I'm going to give it the name of numbers. And to create a new array, there are two ways. You can either use a curly brace, a set of curly braces like that with a semicolon, and you can just say like 1, 2, 3, 4, 5, for example, as your number array. But what I'm going to do here is I'm going to show you the standard way, which is using the new keyword. And I'll explain what that does in a second. So we're going to say new integer, opening and closing square brackets, and then we're going to give it a number. And the number here, 3, specifies the number of places within this array. So this array will hold 3 items. Now, backtracking here, this new keyword is very important in Apex and in many other programming languages, because what the new keyword does is says that we're creating a brand new object, and this object is an array object. As I mentioned before, everything in Apex is an object, but in this case, because we're creating a data structure, which is a complex object, we must specify the new keyword here to instantiate this object. So here we have this numbers array, and within this numbers array, I'm going to add a couple of numbers within it. So to do that, we're going to just say numbers, and we're going to have these opening and closing square brackets. And just to point out, every array or every other type of collection is 0 based. And what that means is that instead of the first item being in the position of 1, the first item would be in the position of 0. So what I'm going to do here is I'm going to specify this in the position of 0. So numbers of 0 is equal to 1. I'm basically taking this value of 1, the number 1, and I'm storing it in the very first position in this array, which is position 0 or index of 0. So we're going to do the same for 2 more numbers. We're going to say numbers, and now the next position will be 1, not 2. So it's going to be of index of 1, which is the second position. I'm going to just assign 2 there. And finally, numbers, index of 2, which is the third position, will be 3. And obviously these values can be everything. I'm just making it simple by using 1, 2, 3 as my values. So what I'm going to do is I'm going to output this just to see what that array looks like. So we're going to say numbers array, and we're going to pass in numbers. All right. So let's see what that looks like in our debug log. Let me just completely clear this out and run this command and look for numbers array. Okay, so as you guys can see here, this is outputting this within a set of parentheses It does not output it as within the square brackets, because in Salesforce they pretty much handle everything behind the scenes as a tuple, as you will, and basically, but it's still a collection. It's still a data structure of the same data type. So you could just ignore these round brackets or round parentheses. Just know that this is an array, okay? Because some other developers from other backgrounds may get confused by that, especially let's say Python developers, because you have tuples and you have like other data types that are similar collections. But yeah, this is still an array. And as you can see, we have 3 items in the array, the number 1, 2, and 3. So that's working as expected. So that's just the basic way of using an integer array. Now you can also create arrays of other data types. For example, you can have a string array. And then a string array, let's say, what do we want to do? Let's say we make an array of animals, a string array of animals. So I'm going to create this array differently here. What I'm going to do here is I'm going to just use the square or the curly braces, and I'm going to create 3, let's give it 4 animals. So let's add in here a string of zebra, a string of horse, string of elephant, and gorilla. Okay, so this is another way that you can create an array. So one way, again, above, you can use the new data type square brackets, and then specify the number, or you can just use simple curly braces. So let's just make sure this works. So I'm just going to output animals array, and we're going to pass in this animals array variable here. Okay, so I'm just going to run this again below, and what I'm expecting to see here, if I search for animals, okay, it's not showing. You might have an error message. Let's see. Okay, so line 161 here. So line 161. Okay, that's weird because that's where we're defining it. It's probably not liking. Okay, I think I know what the problem is. Actually, what we need to do here is we need to say new string, and we don't have to specify the number. So I'm sorry. So should have pointed that out earlier. So we still have to specify new string and then the square brackets. But then we, instead of specifying like a number within these brackets, we can actually just pass in the string values directly. So that's what I forgot to add there. So let me just rerun this and make sure this works now. Okay, and let's look for this animal. And there we have it. So now we have the zebra, horse, elephant, and gorilla, right? So again, there are 2 ways that we can define these. We can actually, again, new integer, specify the number of places or indexes in the array, or the other way is if we don't specify that, we can just give it the number within the array. Now, you might be asking, well, what's the difference? There really is no difference. Generally, you would use arrays if you know that there will be a fixed number of places or a fixed number of items within the array. Now, you can obviously add and remove items from the array as needed, but generally you would use an array over other collection types if you want to keep things nice and simple. And arrays are a little bit more performant in a sense. They run a little faster because they're simpler than compared to like lists or maps, as we'll cover shortly. So generally use an array if it's a fixed length, and use the other ones if you need to have a more dynamic list or more dynamic collections at hand. All right, so let's move on from this a little bit. Let's move a little quicker here. Let's say, for example, that I want to reference a specific item within the array. So let's say if I want to pull out a specific item, I can do that. I can actually output that item directly to the debug log, or I can reference that item somewhere else in my code. So for example, let's say if I want to pull the very first animal out of this array, I want to output this to the debug. So I'm just going to call my debug method here. I'm going to say first animal as the tag. And let's see, I'm going to specify animals here. And I want to get the first animal, so that will be in position 0, because remember, it's 0 based. So let's see if that works. Let me go ahead and run this. All right, and if I do a search for first animal, there we go. So we have zebra getting outputted right here, right? So that's how you get the very first. Now, let's say if I want to get the last animal. So we're going to do another debug here. And let's just say last animal. And to get the last animal, it's a little bit different. So what we wouldn't do is we wouldn't, like, usually we would not say animals like this and, you know, of 3, for example, because we defined it up to 3, you know, the third position, which is really the 4th. We normally wouldn't do that, because what happens if we remove items from this array? This can lead to an array out of bounds exception in Salesforce, so we don't want to do that. What we want to do instead is, if we're not sure how long this array is or how many items are in the array at a given moment, we can just simply within the square brackets say animals, for example, the variable, dot, and then we have, I believe, a size method, and then we can subtract 1 from that. Now, why am I subtracting 1? So what does this mean, really? Animals.size will give us the length of the array. So if the array has 4 items within it, animals.size would return 4, okay, the integer 4. We subtract 1 from that because, remember, arrays are 0 based. So the first position starts at index of 0. So to avoid an error message, we have to minus 1 from this value, which is going to return 3, which is the last item of this array. So let's go ahead and check our work, and if we have errors, we're going to fix it. So let's go ahead and run this, and let's just do a search for last animal, and there we have it. So the last animal is gorilla. So this is basically how you grab the last item in Apex. So it's pretty cool, pretty powerful, done similarly in a lot of other programming languages. And that's what I mean. Like, once you learn a lot of these concepts within Apex, you can transfer these skills to other programming languages because it's written similarly. There may be some differences in syntax or in naming conventions and things like that, but it's pretty much the same concept across the board. All right, so that pretty much sums up arrays. That's what I want to show you as of now. Now, later on, we're going to be covering how to iterate or how to loop through these arrays once we cover loops. And that's a whole nother topic that's a little bit more advanced. But before we get to that, we're going to continue on here by covering collections. So let's scroll back up to the top here. And what I'm going to do is create a new method call called collections. And then I'm going to copy this name, come back down here, and let's create a new method, private void collections, and open that up. All right. Now, just like arrays, collections usually hold many items of the same data type. It can have one or many items, right? You can even have empty collections, just like you can have empty arrays, which are, you know, empty, meaning that they have no items within. But the main difference between arrays, which is a type of collection, but it's a more primitive type of collection, and the other collection, the biggest difference is that these other collections I'm going to cover have special characteristics and special things that they can do. Whether they can hold duplicate values or not, or whether you can easily add or remove items from them or not. Things are handled a bit differently, and it's a lot more intuitive when you're writing code that's a bit more complex. So the very first collection I'll cover here is the list. And what a list is basically a list is a type of collection that, number one, can hold duplicates, but it contains a series of ordered, it's an ordered collection, so it has a series of ordered items within it. So whatever you add to a list will be ordered, or will remain in the order in which you add it to the list. So let me show you by an example. So I'm going to type in here list, and what we have to do is we have to open up a set of angle brackets, and within the angle brackets we need to give it a data type. So we want to have a list of string. So we're going to just pass in string here between these angle brackets. And let's say we want to have a list of cities. So I'm just going to call this variable cities, and we're going to instantiate this by saying new list of string, opening and closing curly parentheses, and then semicolon. So now I just created a new list object which will contain a list of string data types within it. All right. So now to add things to this list, or to add items to this list, what we can do this one of two ways. We can either do it like this, where we have this list of string, and then within this, you can then just add your items like that. But I don't want to do that. What I want to do is I'm just going to use a method called add. So cities dot add, and I'm going to add my cities this way. So it's your preference, however you'd like to do it. I'm just showing you what the list class can do within Apex. So the list class has a method called add. So I'm going to add Berlin as the first city within Germany, like Berlin, Germany. I'm going to add another city. Let's make that my home city, New York. And my third city here, cities.add, will be Tokyo, which is in Japan. All right, so now we have a list of 3 cities, okay? And let's see. What I want to do is first let me output and show you. I won't show you exactly what's within this list because it'll look similar to arrays. What I'm going to show you is how to get something from this list. So how to reference a value from this list. And that works similarly to arrays. So we're going to debug, and let's just say second city. If we want to grab the second city, and that's going to be of the index of 1. Because again, lists just like arrays are 0 based. So we're going to say cities, and we're going to just say cities of 1. So that's going to grab us the second city, which in this case is my home city of New York. So let's go back down here to our debug log and run this and see what we get. If I look for second city, there we have it, New York. So that's getting outputted because it's in the index of 1, which is the second position within the list. So that works just like arrays. Now, again, you would want to use a list if you want to keep things in the order in which they're inserted. And if you have data of the same data type, you can add this to this list. So you can have, for instance, a list of integers, a list of strings, a list of people or person object. Anything that you can think of, you can pretty much add. You can have a list of Salesforce object or a list of S object, in other words. So you can do a lot of things, and lists are used very often within Apex programming, especially when you start dealing with more complex code. You'll probably be using lists a lot more often than you would use arrays, to be honest. All right, so the very next collection we'll cover here is set. Then now the difference between a list and a set is not ordered, okay? So a set is unordered, and a set cannot contain duplicates. Let me show you an example. I'm going to create a set here of string, just like that. So similar to list, the syntax is, and I'm going to call this set names, because we're going to store some names within this set. Use a new keyword, new set of string. Okay. So in this set, I'm going to add, let's add 3 names to this set. Okay. So we're going to say names.add, and the first name we'll add is John. Names.add. Oops, am I spelling that correctly? Katie. And then names.add Jackson. So we have 3 names in this set. Okay. So now I'm going to output this, and let's do something different here. Let's say if I want to know how long this set is. Okay. We're going to say length of set, and we're going to say names.size. Remember, we have this size method, and it's the same method that's on array. This and list also has this. Most of the like list, array, and set have the same size method that you can call to find out how many items are in the collection. So let's go ahead and run this and see what we get. We should get back 3 because there are 3 names in the set. All right, so let's run that and say length. There we go. So we get back 3. As you see, length of set is 3. All right. Now, unlike lists as well, and unlike arrays, we cannot just do, for example, let's say if we wanted to get Jackson, or rather, let's make it simple. Let's say if we wanted to get John, we cannot just say names of 0. That would not work. That would cause an error because, again, sets are unordered, and basically they do not contain duplicates. And the way that they work, they pretty much are more efficient because of the way that they handle data than a list would be. So you kind of lose some of the features that are part of lists, the list class, in an effort to index this information within the set to make it more performant. One thing I want to show you is, as I've been saying repeatedly, that sets do not contain duplicates. So let's say, for example, if I wanted to be slick and I wanted to add another John to this set. So I'm just going to come here and add John, okay? And what do you guys think is going to happen? So we already have this output here to output this size. That's perfect. Let's just go ahead and run this. We just need to simply run this. So let's run this command below. Now, how many of you think that the size will be 4? And how many of you think that it will not change? Okay, pause this and try this. All right, let's look at what the result is. As you guys can see, the result is still 3. Why? Because as I said, a set cannot contain duplicates. So basically what happens is we don't get an error message if we try to insert, but it will attempt to insert, and once it finds that John already exists in the set, it just simply ignores that request to add another John, and the length of the set does not change. So a common use case scenario for set, you would use it if you don't necessarily want to have duplicates in your data. So you would commonly use this for things like ID data type, which also exists in Salesforce, which we can cover shortly. You can use it for other types of data that you don't want duplicates for. If you want to keep data sets unique or data values unique, you would generally use a set to filter through the duplicates, for example. So the next collection we're going to cover right now are maps. And maps are basically key value pair collections. And they generally hold various entries in which the key is unique and is used to index certain values within the collection itself. And this is a common practice that we use if we want to group keys to values and we want to reference that later on. And instead of creating multiple lists and sets and then kind of like looping through them and trying to match on values, we can use a map to simplify that logic a bit. So let me show you through an example. So let's say we create a map, and what I want to do is I want to create a map. Let's say we create a map of inventory, right? We're keeping inventory within a store. So its key needs to be a string, and its value will be an integer. So we'll define it like that, and we'll just call this inventory. And that's going to be equal to a new map of string integer, like that. Our string will be our key, and our integer will be the count of inventory, okay? And again, as I mentioned, the key needs to be unique. So for example, the key would be something like t-shirts or shorts or jeans and things like that. And then the number will be like 10. That would be the count of each item that's in our inventory. All right, so I'm going to add a couple of entries to this map. So we're going to say inventory dot. Now we don't use the add method here. The map class has a method called put. And this will be able to, this will allow us to add a key value pair to the map. So the key in this case will be t-shirt, and then the value, we'll set that to 10. So that means we have 10 t-shirts in inventory. We'll add another entry. So inventory.put. Let's add, let's say jeans. And let's say we have 143 jeans, some random number. And then we have an inventory of belts, or just belt. And that's going to be, let's say 2. Okay, so we have 2 in stock. We're doing pretty well with sales. All right, so let's output this. I'm going to output this map just to see how it looks. So we're going to say map, or let's just say inventory map, inventory map, inventory. Okay, cool, save that. Let's go back down here and run the command and look for inventory. All right, and so this inventory map, as you can see right here, we have our keys and our values. So for example, belt is equal to 2, jeans is equal to 143, and t-shirt is equal to 10. Now if you notice, it's not displaying this in the order of how I gave it, because up here I gave t-shirt as a first entry. So that means that maps are also unordered, unlike list. So maps and sets are both unordered. The difference here is that a map contains a unique key that we can use to pretty much group values, or a set of values, or an object, or whatever the case is, to a particular key within the map. And we can avoid writing more complex logic that involves a lot more collections by just grouping these together within a map and then iterating through that map and pulling data out as we need to. So maps are very powerful, but you have to understand the characteristics and nuances between lists, maps, sets, and arrays. Okay, so let's give some more examples of what map can do. Let's say if we want to get a count of belts. So that means that I want to get the total inventory of how many belts we have in stock. So to do that, I'm just going to say debug here, and I'm going to say belt count. Now, as you remember, we assigned 2 as the value to belt. So to get that value from a map, all we need to do is we need to say inventory, and then we're going to have call the get method. There's a get method. There's a get method in the map class. So we're just going to pass in the belt key. So we have to give it the value, which is the key, right? The key is how we defined it up here. So we have to give that same string here to get that value from the map, that particular entry. And that should return for us the value. So let's test that. What I'm going to do is save this, and I'm going to clear this out below and rerun this command. Go back here, and we call that belt count. And as you can see, it's returning 2 because we, up above, we actually said 2 belts. We specified that this inventory has 2 belts in stock. So this is an example that you would use, for instance, in an e-commerce store, right? You would commonly use like a map or something like that to keep track of the inventory in memory. So you might be pulling this data from a database, and then you can store this in a map and then loop through the map or manipulate the data within the map to make it do whatever you would like it to do. So that's pretty much a common use case scenario. Cool, so that covers maps. Now, there's a few more other things I want to cover here. Let's actually, you know what, before we move on from maps, there is one more thing I want to cover, or rather 2 more things. We need to also know how to get a list of keys and a list of values from this map, okay? So for example, a list of keys, and I'm gonna write a couple of comments. By the way, to create a comment, this is basically code that would not execute. You just use a double / to create a comment, right? If you just want to add a few more points of documentation within blocks of code. So I just want to create these comments: list of keys, list of values. All right. Now, what if we want to get a list of all the keys within a map, just the keys? We can do that by using the dot keys or key set rather method. So to get that, I would say list of string because we want to return a list of keys, which in this case will be a list of string. And I'm going to call this variable map keys, all right? And that's going to be equal to the inventory map dot key set, okay? That should return us a list of keys. So let's output that. Let's just say map keys. And we're going to just say map keys here like that. All right, so let's go ahead and check that. Run the command below. Map keys, where is it? Map keys. Okay, it's not outputting. What am I doing wrong here? He said, let me see. No, okay. Let's see what's wrong here. So we probably have an error message. Where is it? Line 201. Okay, column 18. Okay. Line 201. Let's see what it's not like in 201. Okay. Inventory key set. It's really awkward. Let's see. So I should be getting the key set. We should be getting that back. Map is the string. It's awkward. Oh, you know what? I'm sorry. It should not be a less. And see, this is a great learning exercise here. We're calling key set here. So this is going to return a set of strings, not a list. Okay. We could convert it to a list if we want by saying new list and passing in this, but let's just for simplicity here, just change that to a set of string. Should have caught that earlier. Okay, cool. All right, so this should work now. Let's go ahead and run this. All right, run that. Okay, and let's look for map keys. All right, so there we have it. We have a list of map keys right here. Okay, and as you can see here, it shows belt, jeans, and t-shirt. So that's just the keys. So again, the common use case for that is if we just want to manipulate, for example, the map keys and we want to store that in a separate set, we can definitely do that and we can reference that somewhere else, right? So that's a common scenario. All right, so let's move on to the list of values. So if we want to grab a list of values here, we can now use a list instead of a set because the values can be of any data type. So what I'm going to do here is I'm going to create a list, and we know it's going to be of an integer data type because that's what's in our map. So we have a list of integer, and we're going to call this map values is equal to inventory dot values. And now let's output that. So we're going to say debug map values and pass in map values like that. All right. So let's go ahead and run that. Let's try it again, run that. All right, and let's do a search for map values. Map values. Yep, so here we have it here. 10, 143, and 2 right here. So it's that simple to just get a list of values or a set of map keys from a map, okay? So that pretty much concludes the collections piece here. Okay, so the next concept I'd like to cover are loops. And loops are basically a way for us to cover more lines of code within a more optimized way. So generally, instead of rewriting lines of code over and over again and being a bit unoptimized in our approach, we can use a loop to repeat lines of code and to promote code reuse within our application. And loops are very powerful because within them, we can also add things like control flow statements or conditional statements to control the logic that gets outputted based on a particular condition. So let's just kind of demonstrate through some examples. I'm going to scroll all the way back up to the top. And up here in our run method, let's add another method call called loops. And then at the very bottom, for brevity, because this video is getting very long, I'm just going to copy and paste some examples that I have here. So let's go ahead and paste that in to show you guys. Okay, excellent. So let me scroll back up here to loops and show you. So now basically what I want to show you here are several examples of how we use loops very efficiently within Apex to promote code reuse, and also just to kind of simplify a lot of the logic that needs to repeat on our time, from time to time within an application. So we have different types of loops, such as for, while, do while, which I won't really cover too much because a while and a do while are very similar. But we have for while loops and for each loops essentially. So a for loop pretty much contains a starter variable or a starter value within the variable declaration, as well as a condition and an increment or decrement variable. And generally we set it up that way because we want to be able to loop through a particular collection or a set of values until a condition is met. So here on line 212, we have an example of a for loop where we are setting the integer of I is equal to 0. That's the very the starting point of this loop. So I is equal to 0, and we want to continue looping until I is less than or no longer less than 5. So basically what we're going to do in this loop is we're going to output the value of I 0, 1, 2, 3, 4, and then once I equals 5, this loop will be exited out of. And how that is driven is through this I++ variable declaration right here. What this I++ means is that we're incrementing the value of I by 1 on every single iteration of the loop. So basically this I++ is the same as saying I is equal to I plus 1 for the most part. But this is the shorthand way of writing that code. All right, so great. So now we have here a debug statement where we're just outputting the value of I. So what I'm going to do here is I'm going to run this code to show you exactly what happens here. So let's run this. I'm going to do a search for loop. And as you can see here, we're actually looping through 0 through 4. And the reason why we're not outputting 5 is because we're checking to make sure that I is less than 5. Because once I equals 5, this loop will be exited out of. So that's how a for loop works. You always have a counter variable, which is I in this case, that drives the logic itself. The looping mechanism is the counter variable. Now let's move on here. So the next type of loop we have is a while loop. And the difference between a while loop and a for loop is that the while loop does not internally contain this counter variable. Normally you would define a counter variable outside the while loop, and then you would increment within the while loop to control the flow of the loop itself, the execution. And the main difference, the main reason why we would use a while instead of a for loop in some cases is that we would use a while loop when we're not really sure how long a loop should execute. We just want it to execute until a certain condition is met. Whereas with a for loop, we usually have more of an idea of how many items are in a list, for example, or what a given condition should look like. So we generally would use a for loop. I'll tell you that pretty much the breakdown there is that I generally use for loops most of the time, like I would say 85–90% of the time. And then I might use a while loop if I'm not really sure, if I'm kind of leveraging, a value being outputted by an event or some sort of delegation within the application, then I would use a while loop to control the execution of the loop. So here's an example of a while loop. The very important thing here is when you're dealing with while loops, you have a concept, which is a bad one, called infinite looping. And infinite looping usually occurs when you don't have a counter variable specified within the while loop or outside the while loop, and then the loop continues to loop for eternity, forever, or at least until a Stack Overflow exception is thrown. So what we generally want to do is when we deal with while loops, we want to first define a counter variable. So that's what we're doing here. We're saying integer count is equal to 0. And then we use the while keyword to specify the while loop. And then within the while loop, we have our condition. So here we're saying if the count is less than or equal to 3, then we're going to output this while loop tag and then output the value of count. Now, if you notice right below this output statement, we have this count plus plus incrementer operator, which is the plus plus part. And basically that's going to increment the count by 1 on every single iteration of the loop. If we were to take this out or comment this out, this would cause an infinite looping scenario because count will never equal 3 because we're never incrementing. So again, just to kind of reiterate in case you missed that, count is equal to 0 before we start the while loop. Once we go into the while loop, we check to see if the count is less than or equal to 3. In this case, it's 0, so this would be true. So then we would execute this code here. And then if what I'm saying is if we don't have this count variable, let's say this was gone completely, and we just had this line of code here, because we're never incrementing the count by 1, 2, 3, and so on, every time this loop would repeat, count will always equal 0 because we're never incrementing, which means that essentially this loop will never end. It will go on for eons and eons for eternity, an eternity. So you definitely want to make sure you have this incrementer operator or this variable being incremented within the while loop, so that way it knows when to exit. So once it hits 3, it's going to completely exit out. And obviously this code is going to output 0, 1, 2, 3. So let's go ahead and run this and make sure that's what we see here. And I guess I could have just looked at the prior log, but it doesn't hurt to run it again. So as you can see here, we have 0, 1, 2, and 3. And that's because we're saying if it's less than or equal to 3. If we just said less than, it would just output 0, 1, 2. All right, so let's move on here. Now we can also use something called a for each loop. And a for each loop is generally used when we have a collection or an array and we are not really sure how many items are in that array. We just want to continue looping until the very end. Then we can use a for each loop. And in my opinion, a for each loop is one of the simplest, if not the simplest loop to use in Apex. So here on line 223, what I did is I created a double array. So an array of double values, double numeric values, which are floating point numbers or decimals. And I'm defining temperatures. So in this array, so we have 24.5, 13.3, 100.4, and 85.3. Now further down, I have a for each loop, which is constructed like this. We have the keyword for as we did above, but the difference here is we have a double data type, which represents the type of entry that we have in this double array. So we define double, and then we have this temporary variable called temperature, which represents any single given item within this array. So for each, this reads as follows: for each temperature in temperatures, which is this array of doubles, all we're going to do is output the temperature itself, the single item. And this will continue to loop until we reach the very end of the array. And I want you guys to notice that we don't have any counter variables here. Excuse me. Basically, we're continuing to loop until the array, the entire array, has been cycled through. So let's take a look in our debug log. As you can see here down here, we're just doing that. We're outputting every single value from this double array. So this is working as expected. Cool. So that's how a for each loop is used. Now, generally, when I develop for clients, I use for each as often as I can. Usually I look to see, well, what's my scenario? Do I really care about how long the collection is that I'm looping through? Can I simplify matters by using a for each? Because I find that for each loops look a lot simpler than the other loop types. So I would say, as a rule of thumb, and it's based on your preference, you can do as you wish, but as a rule of thumb, I would use for each in most cases wherever applicable. And then I would default to for, the regular for loop, if I just need a counter variable and I just need to increment or decrement, which will be a double minus sign, through a loop or through a collection. And I only would use a while when I'm not really sure 100% how long something should loop for. And it may not be based on the length of a collection. It could be based on any condition. But I generally would only use for each for collections because it's a lot simpler to read and to write. So let's move on here. Let's say, for example, I want to demonstrate the different ways that you can write these loops. So here I have a list of groceries which contains strings. And we have generally, apples, we have grapes, meat, and water, 4 items in the list. There are 2 ways you could write this with a for loop and a for each loop. Now, the first example I'm giving here is with a for each loop, where we're looping through each item in the groceries list. And then we're just outputting that item. So literally 3 lines of code and very simple. Now, the next example is using a standard for loop, which is also 3 lines of code. But as you can see, because we have the counter variable initialization here, and then we have the condition, which is I is less than the size of the list of groceries, in this case 4. So while I is less than 4, and then we increment I is equal to I plus 1 on every single loop iteration, then we output groceries, and then we pass in I as the index, as we have been doing above with names of 0, names of 1, and so on. Because on every single iteration, I will equal 0, then 1, then 2, and that will just output every single item in the list. So looking at that, these 2 loops do the same exact thing. But the main difference is the complexity of the code, as you can see. So let's look below here and see what we get as an output. So in our debug log, as you can see down here, for the grocery item, which is the for each loop, we get back an ordered output, because this is exactly the same order of how we inserted these items in the list. We're getting back our items in the same exact order. And looking further down, looking at the for loop version, starting right here, we're getting the same output. So now I think it's completely based on preference whether you would like to use a for each loop or a standard for loop to do the same exact thing. I think you have to kind of play it by ear. And I would say, again, as a rule of thumb, if you need a counter variable for whatever reason, a common example would be, for example, if you wanted to check the value of I on a certain iteration, if you wanted to say if I is equal to 2, output a certain message if I is 2, then you might want to use the standard for loop. Because then you can have access to the counter variable, and then you can add control flow statements within it to create special logic given the value of I, for example. But other than that, in most cases, you just need to loop through a collection, and then you need to pull data from that collection. So in most cases, I'd say 90% of the time, you would probably use a for each loop in that case. All right, so going further down here, we can also do the same exact iterative process when dealing with other collections. So in the case of a set of string, here I define a set of string of cards, which contains a set of suits, card suits. We have ace, jack, king, queen, and joker. And then all I'm doing here is I'm using a for each loop for each suit in cards. I'm just outputting the suit. And let's scroll down here to see what we get. Where was I? Okay, so right here, as you can see, we're getting the current suit. And it's getting outputted in any order. It's not a particular order, right? Now, we just so happen to see that it's pretty much in the same order that I inserted it. So we got lucky there, right? But in most cases, you can't rely on the order being exactly the same, okay? When you're dealing with the set, because it's an unordered collection. But as you can see, it's a simple for each loop that's outputting the values. So now when it comes to maps are a little bit more complex, but we can actually loop through either one of 2 things. We can either loop through a set of keys or a list of values. So here I define a map using shorthand, and this map represents the capital cities of certain regions in the world. Not necessarily countries, but regions. So we have here an entry. The first entry is New York, and the capital of New York is Albany. And then we have a second entry that the capital of Switzerland is Bern. I think that's the unofficial capital. I'm not sure if Switzerland has an official one, but most people consider Bern to be the capital of Switzerland. And then finally, for the United Kingdom, we have a capital of London. I know. If you're from the UK, please don't slay me if I'm wrong. I'm not 100% sure if London is the capital of the United Kingdom, but I think it is. I'm an American. What do I know? All right, so moving on here. what we need to do here is loop through this map. So that's what we're doing here. We're looping through each region, but if you notice, we're looping through the set of keys or the key set. So what's happening here is when we loop through a map using a for each loop, the very first thing we do is we specify the data type, in this case, the key that's specified up here in this map of string to string is a string in itself. So that represents the region or the very first key entry here. So New York, Switzerland, and United Kingdom would be the region. And then we're pulling out the key set, which gets returned as a set, right? We're outputting the region right here. And then right below it, we're also going to output the value or the capital city of that region. So to do that, we just say capitals.get, and then we pass in the key, and that returns the associated value with that entry. So let's look down here in our output here, and as you can see, we are getting back our capital cities, right? We're getting back Albany, we're getting back, for Switzerland, we're getting back Bern, and for the United Kingdom, we're getting back London. Okay, so that's how you loop through a map's key set. You can also loop through a list of values in a map. So down here, another for each loop where we just loop through the capital cities, which is a list of string. And then, so this temporary variable of capital is a data type of string. And basically here, we're just passing in this tag and the capital city. So if you look down here, you can see that these are the outputs. And basically, we would use the .values method instead of the .key set if we don't care about the map's keys. If we just want the values from the map and we don't care what it's associated with, we would use the values method instead of the key set method. So if we want both the keys and the values, use key set. If you just want the values, just call the values method on the map class, and that'll do it. All right, so that pretty much covers loops. I wanted to kind of just paste that in and go through it because there's a lot to write out, but feel free to pull this code down from the repository and look at other examples. You can also write this code out right now, but I would also just kind of create your own examples and practice as you go along because that's the best way to learn. All right, so I think we got one more topic to cover here, and it's actually we got two more topics I'd like to cover. And the next one will be classes. So let's go back up here. And the very first thing I want to do here is I'm going to, again, just like we've done the entire course, is create a class called, or a method called classes. So I'm going to scroll back down here. Private void classes, and open and close that. Okay, so now classes are very important. Because a class is a blueprint of an object. So it's basically a template. What I mean by that is, in object-oriented programming, the term object reflects pretty much two things. The state and the behavior of a particular object is reflected through its variables and its methods respectively. So for example, in your application, you may have a person object or a person class, and that person class will have state. The state could be the age, the name of the person, where they live, the year that they were born in, and so on. Whereas the behavior would be the methods such as say hello, eat, sleep, drink, and so on. So, a person class will have state and behavior, and generally a person class synonymously can be a person object because the object gets created when we instantiate the class. And I'm going to show you several examples of how that works here in Apex, but just understand that across many programming languages, in fact, most of the object-oriented programming languages follow the same paradigm in which you would instantiate a class to create an object, which is a template the class is a template of that object. So I guess we can start off by creating a new class, and that's going to be a new Salesforce DX command that we're going to have to learn. So let's go back to our terminal here. So in order to create a class in Apex using Salesforce DX's CLI, we're going to type in this command. It's going to be sf apex. Let's see, I think it's sf apex generate class. Let me refer here. Okay, dash n. So sf apex generate class dash n, and then we give it the name of the class. We're going to create a person class. So let's just type in person with a capital P here. And let's see if I want to give it something else. Okay, let's also specify where we want this class to go, because as it stands, if we just run this command as is, what's going to happen is it's going to create this person class, this person.cls class within the root folder of our project. And we don't want that. We want everything to be kept where they need to be, especially when it comes to the metadata files that's associated with each class. So to specify the location at which we would like this file to be created, we just give it a -d flag, and we say force -app main default, and then we're going to say classes, because that's the name of the classes folder, the Apex classes folder. And I think we could just hit enter, and let's give that a few. Sometimes it takes a while to create that. Okay, so I think it created it. So now if we go here to our folder directory here, to our folder here, and we open up Force app, and then we go to classes, as you can see, we have a person class here now. So let's open that up. And here we have the boilerplate template for the person class. So let me just kind of walk you through what you're looking at right now. So what we did is we ran this command, this CLI version 2 DX command, to create this class in Salesforce. And again, as I said, a class is a template for an object. It's a blueprint that describes the state and behavior of an object. So here we see public, which is an access modifier. If you recall, in our script file, we've been using private void the entire time, or private. And private is an access modifier, which means that no other part of our application can access that particular method or field or variable. In this case, this class is marked as public, which means any part of our application can call this class, can access this person class. The with sharing keyword is Salesforce specific. Basically, it allows us to share any underlying data that is a result of this person class with anyone whose sharing rules comply with this. So basically in Salesforce, you have the concept of sharing rules, and they allow users to access certain records data based on the permissions that they're given within the sharing rules. And when you mark an Apex class as with sharing, when the code is compiled and executed on the server, is going to check what the sharing rules of the current context user is. And then if the context user has insufficient permissions, this Apex class will not fully execute all the data. It won't be visible to the user. In some cases, they might see an error depending on what you're doing. But if the user has sufficient permissions, then the user will be able to access all of the underlying data and that's within this class, or anything that this class references. So it's very important if you want to enforce security and data, prevent like data breaches and stuff like that. You mark this as with sharing, and that's the reason why this was marked as with sharing by default by the IDE. And then you have this class keyword, which just simply sets this up as a class, and then finally the name of the class, which is person. Now within the brackets here, we see also public person. This is called a constructor, and I can just mark that as that so you guys can see this. Now, what is a constructor? Well, you have the word construct, and the word construct means to build, right? So what we're doing when we define a constructor in a class is we are building a brand new object. And when we build this object, generally this object, in a sense, will be accessible outside of this class, and we can pass certain arguments or parameters to this object, so that way we can manipulate the data within the person class, or we can call the methods within. So this constructor will help us to initialize the first set of values, in this case, within the person class. And this is a very sleek and clean way of setting up your code. So the very first thing I want to do within this person class, let's see here. So let's start with the constructor. So what I want to do with the constructor first and foremost is I want to pass in two arguments. The first argument will be a string of name, and the second one will be an integer data type of age, because we're going to just set an age and a name for this person. Okay. Next up, what I want to do is I'm going to go above this constructor here, just make some space, and on line number 2, I'm going to define what are called fields, some private fields. So I'm going to say private string of name, and then private integer of age. Okay, so these are fields, and the fields are types of variables that generally you would define at the top of a class. And the reason why you would do it like this is a common construction. It actually originates from Java programming. But the reason why you generally would like to do this is because you may not want to expose these fields directly outside of this class. So instead of giving direct access to these fields and having the user, having us mark this as public and then the user can access these, what is a common convention is that we would pass in the name and the age to the constructor, and then we would set the values of those arguments to the fields, these private fields up top. So to do that, for example, you would say this keyword dot name is equal to name, and this dot age is equal to age. Okay, so just to explain what's going on here, this keyword refers to this class of person. So whenever you see this, think of this as referring to the class that it's in within this scope. So this dot name, or this field up here, name, we're setting that value to the value that we're passing in through the constructor, which is name. Okay, and then the same thing goes for age. We're just setting age of the field to whatever value we're passing in through the constructor. And that way we don't have to expose these fields directly outside of this class. They can remain private. Okay, hopefully that all made sense, because it's definitely a mouthful. Next up, we're going to define some behavior. So let's create a new method. We're going to call this public void greet. Now notice the difference here. I'm saying public void, not private, because I want this to be callable without, sorry, I want this to be callable outside of this class, if you will. All right, so what I want to happen is whenever greet is called, I just want this person to greet to greet the user. So we're going to say system.debug, and let's type out a message here. Let's say hello. My name is, and we're going to use string concatenation again. Now, I want to output the name, so I'm just going to say name, and I want you to understand that this name field is not what's coming in through the constructor. Even though it's the same exact name of the variable, this name refers to the name field here on line number 2. It does not refer to this name here that's coming through the constructor. Remember, we're saying this dot name, and so that it would be down here. We can also, to make things clear, say this dot name as well down here. It's the same exact thing. You can either use name or this dot name, but in this case I'll use this dot name so there's no confusion. Okay, so that's the name. We'll add a period and it'll say, okay, my name is whatever it is, and then I am, and then let's add an age, and that's going to be this dot age, years old. All right, and that should do it. So that's our behavior. Now there is one more method I'd like to define, and that's going to be whenever I call this method, the age will increment by 1. So I'm going to call this increment age. So public, we're going to return an integer. So this is something different here. So public integer increment age. and this is just going to be returning this dot age plus 1. Okay, so we're just incrementing the age by 1. Now this may seem rather new to you because we haven't covered any other return type other than void. Normally we write public void or private void, but in this case we're doing public integer. And that's because we need to return a value to the caller or whatever block of code will call this increment age. And I'll show you this shortly exactly how this works. But when we call this method from outside of this class, it's going to return the age plus 1. So if the age is 10, once this code gets executed, it's going to return 11. All right. So, okay, good. With that being said, I guess we can go back to where we were with examples. Okay. And so we've created this new classes function. Now, generally what we want to do is we want to create a brand new object. Okay. So let's do that. Let's create a new object from the class we just created. So we're going to say person with a capital P because we created the person class, and we're going to say person with a lowercase p. Now, this does not cause a conflict because one is upper and one is lower. However, let me just, as I'm saying this, I'm thinking of something. Salesforce Apex works very differently when it comes to case sensitivity. Generally in Apex, certain things are case insensitive. So when you're referencing, for example, object names in Salesforce, standard objects or custom objects, you can usually write them with lower or uppercase and it will accept that. So you know what, just to avoid confusion, I'm just going to call this, let's call this person, or actually let's just call this P1. So P1 is equal to new person. All right. All right, so all we're doing is creating a new person object. This is similar to creating like a new list and a new set and so on, but instead we're creating our own custom data type, which is person. So person P1, we're going to store a reference to this person in memory in the variable P1. Now, as you recall, in the constructor of this class, we're actually passing in a name and an age. Let's go back there. So we're passing a name and an age. So let's go back to examples and let's do that. Let's say that the name of this person is Reggie and his age, which is an integer, is 45. So now we're passing this to the constructor. So whenever we call new person, we're basically calling the constructor to create an object. Okay? All right, so now that we have that set up, now let's call greet because we want to get to know Reggie. So let's say P1.greet. Okay, and that should show. I'm not sure why it's not showing. Okay, let's try it. P1.greet. It's not showing. So let's go back here. It should show an autocomplete. So there's something wrong somewhere. Let's go back to our class. No, it looks perfectly fine. Let's go ahead and run this and see what happens. So let's go back to examples.apex, and I'm just going to run this and see if we see any error messages. Let's clear this out. Run the command. And I believe that the message started with hello. Okay, something's wrong here. Okay, I think I know what's going on here. All right. So this is a perfect example here. So this is a learning exercise. So now, if you notice, let's just go back here. If you notice, when I was trying to call the greet method, nothing shows up here, right? There's no auto suggests. And this is a trick of Visual Studio, okay? The reason why nothing shows up here is because we haven't yet saved this code on a server. So up to now, we've been writing a lot of our code anonymously, right? We've been executing anonymous scripts because all we're doing is working with, fundamental Apex concepts. We have not been really dealing with anything related to classes or data or anything like that. So generally, what we need to do now is we need to be able to save this code on the server so that way we can call it, because we're creating a person class. So we need to be able to save this code on a server so that we can run this, right? So let's go ahead and do that. So to save this file on the server, we need to run a simple command in our terminal here. So what we're going to do is we're going to run sf project deploy start. And here we need to specify the alias as well as the file. So we're going to do a -o, and we're going to say Salesforce Apex Crash, which is our alias, and then -d force app main default. And what we want to do is we want to push up this person class. So it's going to be person, and you probably can't see this. Let me just get this search bar out the way, but it'll be person.cls. Sorry, that's going to be in the classes folder, and then person.cls. So let's try that. Now this should be up on the server. So now if I rerun my script here, which is this command, and let's check our debug logs. See, let's check for the greet, which was the hello. As you can see right here, it's here. So basically now we're saying, hello, my name is Reggie and I'm 45 years old. So that works perfectly. So finally, we've reached our final concept here, and we're going to basically cover exception handling. So what are exceptions? Exceptions are generally error messages or errors that exist in our system whenever we don't, whenever something happens unexpectedly and we don't know exactly where it's coming from. What would happen is an exception would get thrown, and that would normally halt the execution of your application. And they're very dangerous if they go unhandled. So what we're going to learn right now is how to handle exceptions very gracefully to avoid or minimize these kind of unexpected situations from happening. So back in our run method, we're going to create another method called to exception handling. So we're just going to create a method called that. Let's copy this name. Let's go back down here, and at the very bottom, we're going to say private void exception handling and paste that in. Okay, so to handle exceptions or error messages that occur in Apex, we generally would use a try-catch block. The try portion of the block would be where you would normally define your regular code that you kind of suspect may have an issue or cause an exception. And then your catch block will be the part that will gracefully handle the exception when it occurs. Let me demonstrate what I mean. So first we're going to write try here and open up a set of curly braces, and here, down here, we'll define our catch. So the very first example I'll give is, or the only example I give in this case, is the divide by zero exception. And this is very common across many different programming languages. So this happens normally when you take any number and you divide it by zero. It normally throws a math exception in Apex. So let's create this scenario to just demonstrate. Let's create an integer. Let's say num1 is equal to 10, and then we'll create another integer where num2 is equal to 0. And now the line of code here will define integer result. This is going to be the line of code that's going to cause this exception. So we'll say num1 / num2 to try to divide these two numbers. We're dividing 0 into 10. Now I do expect this to throw an exception in most cases. In most programming languages it will, because we're trying to divide by 0. And this is kind of like a safety net so that developers are more disciplined when working with numbers. That's the reason why they're kind of forced to write this try-catch logic. In Apex, we have a class called math exception. So let's type in math exception. And the math exception is an exception class that pretty much is thrown or risen as a result of an exception being thrown related to mathematical calculations. So here we have to specify a variable name to represent the exception object. And within this catch, let's just output whatever the error message is as a result. So we're going to say here, math error. And here we'll say mex.getMessage. So the get method within the math exception class will actually output what the issue is for us to the debug log. Now, there may be circumstances where there may be other types of exceptions that will get thrown prior to this line or after this line, and we may not know what they are. So in that case, we may not be fully protected if we just, bank on it being math exception. So what we need to do is add another leg of code here to cover all other types of exceptions. So we can do something like this. We can say catch, and we can say exception, and we'll just call that EX. And then let's just output here an error occurred, and then say ex.getMessage. Let's not get that, let's get message. There you go. Now basically what that will do, the exception class here is actually the parent class to all exception classes. So for instance, math exception is a child of exception. So any behavior that's defined within the exception parent class can be extended to the child exception classes, which math exception is a child of exception. That's the reason why math exception can also call get message, just like exception can. It actually originates from the exception class. So now this is going to capture any other type of exception. So for instance, if we're calling an API externally and then there's a callout exception, that will be caught here. So now you might be asking, well, why do I need the math exception when I could just use exception instead and just kind of save all lines of code? General rule of thumb, you want to be as descriptive and as precise as possible. Even though there's less lines of code, you may be able to cut down a little bit of CPU time if you're more explicit in what you're looking for. In many cases, I may never use this exception EX. I might just use the specific exceptions I'm expecting, right? But in cases where I'm not really sure what kind of exception it is, then I go with the exception EX because that's the catch-all to everything, all right? So hopefully that makes sense to you guys. So looks like everything is done here. Let's just go ahead and try to run this. All right, so let's do this command here. We're going to do this apex run command and hit enter. And we get an output. So let's see what we get back. So let's check for math error. And as you can see here, we're seeing math error. So, and it says divide by 0. So there we go. So we're getting an error message because we're dividing by 0. Now, obviously, this line never gets hit down here because we're catching the exception up here. So that's all we generally need. If we had removed this line, let's say if we remove lines 276 to 277 or 278, and we just left this exception here, then it would still get caught, but it would output an error occurred divide by 0. And the reason why is because exception would still capture or catch rather that exception, that error message. So it looks like we're good here. I mean, that's pretty much what exception handling is, and you can get really, really complex with it. And a common use case scenario is you generally would not just output to your debug logs. Generally what you would do is you would output this to a database object or an S object that is sort of like a debug log object. So for example, in Salesforce, you would create like a debug log object that would capture, or like an exception log object. And then you would write the exception directly to that object, and then have a team of developers look at this, or maybe an admin or someone like that who's technically advanced, look at it, and then they would troubleshoot and triage the error message, and then just kind of conserve on space because those can add up pretty quickly. You could probably put like a purge script in there to delete those records after like 7 days, 14 days, and so on. So that's a common thing that I do because exceptions can happen at any time, and the worst thing you want is to get called in on the weekends to try to figure out exactly what's going on. It's a bummer. So yeah, I mean, that's pretty much exception handling. That's what I wanted to show you, and that pretty much concludes this course, guys. It's been a lot of fun showing you the very basic fundamentals of Salesforce Apex. I want you guys to keep in mind that I will be coming out with more videos specifically around Apex triggers and working with SOQL and eventually working with Lightning Web Components and Aura components. So stay tuned to that. Make sure you like this video. If you love this course, subscribe and hit the bell icon to stay updated on future videos. And you know what? I just want to thank you for just supporting this channel. It's growing, and hopefully we can get more and more people to just become aware of this channel. And I really enjoy making these videos. So with that being said, guys, happy coding and enjoy your time writing some beautiful code out there. Take care.